Welcome back to Sleepless Mysteries. Sometimes mysteries do not come alone. Sometimes they arrive as echoes, as patterns, as visitors who seem to follow one another through the dark. In 2017, astronomers detected an object that shook science itself, Oumuamua. It was the first confirmed interstellar visitor ever seen by humanity. It did not look or behave like anything we had expected. Long, thin, tumbling silently, it moved in ways no comet or asteroid should. Its acceleration defied gravity, and its shape sparked debates that continue to this day. Was it rock, ice, or something else entirely? When it vanished into the void, it left only questions behind. Then, just a few short years later, another visitor came. On July 1st, 2025, astronomers confirmed the discovery of 3 Atlas, the third interstellar object ever recorded and perhaps the most mysterious. Like Oumuamua, it came from beyond our sun. Like Oumuamua, it refused to behave as science expected. Its path bent strangely, its light shifted oddly, its story just as incomplete. 2 visitors, 2 anomalies, 2 riddles drifting across the galaxy and pausing briefly in our skies. And so a new question emerges. What if Oumuamua was not alone? What if it was only the first, the scout, the one that came ahead to measure the unknown? What if Atlas is part of a sequence, a pattern of travelers from elsewhere? Not random wanderers, but something deliberate, something watching. Across the ancient world, comets and lights in the sky were seen not as chance, but as signs. Babylonians carved them into clay. Chinese astronomers tracked them with precision. Greeks and Romans recorded them as omens of change. They believed the sky did not move without reason. And when we look at Oumuamua and Atlas together, we are left with the same thought. Is it coincidence or is there meaning in the sequence? These are not inventions. They are facts, measured and studied with the best tools we have. Yet, with each visitor, science finds itself uncertain. Why did Oumuamua accelerate as though pushed? Why does Atlas glow and shift in ways no model can predict? And why, of all the billions of stars, did they both pass through here through our small corner of the galaxy within such a brief span of human time? You don't need the images to feel the strangeness. You don't need to see them racing across the black to sense the unease they stir. Just let the words guide you. Close your eyes if you wish. Imagine the infinite dark, a silence unbroken, until suddenly an object cuts across it, moving with purpose, vanishing before you can understand it. Imagine another follows as if in response. One scout, one shadow, one question that lingers still. Before we begin, if you haven't already, subscribe to Sleepless Mysteries so these journeys into the unknown will always find you. Tap the like button if these stories bring you calm or curiosity. If you're still awake, share in the comments where you're listening from and what time it is right now. Now, let the present fall away. The visitors have come, and the question remains, was Oumuamua just the scout? This is 3 Atlas. Could Oumuamua have been just the scout? Unsolved Mysteries for Sleep, and it begins now. The interstellar silence. When 3I Atlas streaked into our solar system, it did more than challenge the mathematics of celestial mechanics. It brought with it a silence that seemed almost deliberate, as if the universe had gone mute around its passing. Every comet, every asteroid, every visitor that crosses our cosmic neighborhood tends to carry with it a family of fragments, dust, or other companions. Yet 3I Atlas arrived utterly alone. This absence raised a question so unnerving that astronomers struggled to articulate it publicly. Why was there nothing else in its wake? If nature tends toward chaos, with trails of debris and gravitational followers clinging to interstellar wanderers, then this perfect solitude stood out like a siren. The silence was not only physical, but observational. Radio telescopes turned their ears to the sky, expecting at least the natural whispers of charged particles bouncing off its surface. Instead, they picked up nothing distinguishable. For scientists accustomed to the background noise of the cosmos, that kind of silence was deafening. Even comets beyond Neptune hum faintly when probed by our instruments, their interaction with solar radiation producing detectable signals. But 3 Atlas refused to sing. The result was an unsettling quiet that some compared to walking into a forest where even the insects have stopped chirping, the kind of quiet that precedes something extraordinary. This silence fueled a darker suspicion. Was the void around it manufactured? If 3I Atlas were natural, its interactions with the interstellar medium over millions of years should have left scars, trailing dust, or even faint electromagnetic signatures. Instead, astronomers described it as sterile, as though scrubbed clean of anything that might give away its true identity. To believers in artificial origins, this was not coincidence, it was camouflage. A probe designed to pass notice would not only mute itself, but erase its trail, making it seem less like an intruder and more like an invisible traveler just beyond the limits of curiosity. Tracing its silence back through the void, researchers attempted to identify its birthplace. Normally, by charting a body's trajectory, astronomers can approximate which star system it originated from. But with 3i Atlas, every calculation collapsed into uncertainty. The object seemed to have come from everywhere and nowhere at once. Each attempt to triangulate its path led to a different possibility, scattering across constellations like dice rolled onto a cosmic table. The silence was not merely about the absence of noise, it was about the absence of answers. What struck observers most was the contrast between 3i Atlas and its famous predecessor, Oumuamua. When Oumuamua passed through in 2017, it left behind controversy but also measurable anomalies, shifts in speed, strange reflections, a brief but chaotic trail of data that astronomers could at least argue about. 3i Atlas, by comparison, was more reserved, almost cautious. Its passage suggested intelligence, or at least intent, the way a shadow might glide across a wall without touching anything in the room. It was the difference between a stranger slamming a door behind them and another slipping in unnoticed, leaving no trace. One of the most haunting aspects of this silence was how quickly 3 Atlas disappeared from observation. For an object that should have captured the world's imagination, it was strangely neglected in the public sphere. News outlets gave it brief coverage, then moved on. Funding for extended observation was scarce. Within months, it had slipped from headlines into obscurity. The silence extended from the object itself into the way humanity responded to it, as if some invisible hand had muted both the cosmic visitor and the voices of those who might have cried out about its mysteries. This strange quiet gave rise to conspiracy theories. Was data withheld? Did certain observatories record more than they revealed? Some speculated that hidden transmissions had been detected and quietly locked away, not because they proved alien life, but because they proved intent, something worse than random chance. A natural object would be puzzling, but an engineered silence would suggest watchers who preferred to remain unseen. For civilizations with the technology to send scouts across interstellar space, silence could be the greatest weapon. It hides motives, it hides presence, it hides the next step. For ancient cultures, silence often carried a sacred meaning. Prophecies from Mesopotamia spoke of the star that comes without sound, a celestial wanderer linked to omens of destruction or divine visitation. The Mayans believed in silent suns that passed unseen until their consequences were felt on Earth. Even Norse myth described the Fimbulwinter, the great silence before the twilight of the gods. Whether coincidence or echo, the silence of 3 Atlas seemed to resonate with humanity's oldest fears, that the universe could speak in symbols, and silence itself was the message. If we imagine 3i Atlas as a scout, then the silence might not be accidental. A scout announces nothing. It observes, records, and reports. Its purpose is to leave no footprint so that whatever follows can arrive without warning. Some astrophysicists, quietly and off the record, compared the timing of 3i Atlas and Oumuamua to the arrival of reconnaissance probes in a military campaign. First a loud decoy, then a quiet observer. If this were true, then the silence was not just mysterious, but ominous. It meant something else could be listening, watching, or preparing. Yet, others see the silence as a reminder of our own limitations. Perhaps the signals were there all along, too faint for our instruments to perceive. Our telescopes, advanced as they are, still struggle to capture the fine details of an interstellar fragment racing through space at impossible speed. The silence may belong to us, not the object. In this interpretation, the mystery is not what 3i Atlas chose to hide, but what we failed to hear. Even now, years later, the silence of 3i Atlas lingers. Scientists publish cautious papers about its possible nature, always hedging with perhaps and maybe. Yet the feeling remains that something essential was overlooked. Silence, after all, is rarely empty. It can be intentional, it can be meaningful, and in the case of 3i Atlas, it can be haunting. What makes this mystery endure is not what we learned from 3i Atlas, but what we didn't. No echoes, no trails, no answers. Just a visitor that came and went, leaving nothing but silence behind. And sometimes silence speaks the loudest of all. The timing problem. When 3I Atlas entered our solar system, the strangest question wasn't just about what it was or where it came from, but when it arrived. Its timing was so uncanny that even cautious scientists admitted it was almost suspicious. In the vastness of cosmic history, with billions of years in which such an object could have passed by unnoticed, it arrived precisely during a sliver of time when humanity possessed the instruments to detect it. 100 years earlier, it would have slipped past in total secrecy. 100 years from now, perhaps, we'd be equipped to chase it with interstellar probes. But in the early 21st century, just as humanity was learning to stretch its gaze beyond its home star, 3I Atlas appeared. The odds of this coincidence stagger astronomers. For most of human history, our species looked at the stars with the naked eye, unable to detect anything smaller than a planet or brighter than a comet. Only in the last few decades have telescopes reached the level of sensitivity required to notice fast-moving, dim objects from interstellar space. To catch such a fleeting traveler required timing so precise, it bordered on improbable. The question arose almost immediately. Was it pure chance or something more deliberate? The problem deepened when comparisons were drawn with Oumuamua, the first interstellar object discovered in 2017. For billions of years, Earth saw nothing like it. Then, within just a few years, not one but two interstellar wanderers appeared in our neighborhood. Both were recorded by modern instruments, both sparked controversy, and both left behind mysteries we couldn't solve. For many, this wasn't random coincidence, it looked like a pattern. Consider the timeline. Humanity built its first modern radio telescope in the 1930s. By the 1960s, SETI was listening for alien signals. In the 1990s, wide-field sky surveys became advanced enough to scan for near-Earth objects. By the 2010s, technology allowed automated software to flag faint anomalies moving at unusual speeds. Just as this capability matured, Oumuamua appeared. And only 3 years later, 3I Atlas. The timing aligned almost perfectly with humanity's arrival at the threshold of interstellar awareness. Skeptics argue that this is no more than statistical inevitability. The more we look, the more we find. If telescopes had been watching in the 1500s, we would likely have detected interstellar objects centuries ago. But others counter that we have scanned the skies for decades and found nothing until now. The abruptness of these discoveries, arriving close together, suggests that either the frequency of visitors has changed, or something about our cosmic neighborhood has attracted them in recent times. The timing also resonates with something deeply psychological. Humanity has long imagined that when we were ready, the universe would reveal itself. Ancient myths are filled with prophecies of signs in the heavens appearing at moments of great transition. The arrival of 3I Atlas during our technological adolescence felt to some like an echo of those stories. We are on the cusp of becoming a spacefaring species, beginning to send probes beyond the solar system, and just then, two strange wanderers cross our path. The mythological mind whispers, "This is no accident." To scientists, however, the timing posed practical headaches. Why now? Why during a period when observation windows are limited, funding is scarce, and debates about priorities divide the astronomical community? If this was the moment the universe offered us a puzzle, it was a cruel one, arriving when we lacked the resources to chase it fully. By the time debates about funding missions were settled, 3I Atlas was gone, slipping back into the darkness. The timing problem becomes sharper when you consider the sheer improbability of noticing such a thing at all. Objects like 3I Atlas move fast and are faint, often invisible until they are already close to the sun. If it had passed slightly farther from Earth, or if the surveys that detected it had been down for maintenance, humanity would never have known. That it appeared during one of the rare windows when instruments were both pointed in the right direction and functioning correctly adds yet another layer of uncanny timing. Some researchers wondered if the timing was engineered. If an advanced civilization wanted to make its presence known, or at least test whether we were capable of noticing, they would time their probes to coincide with humanity's technological awakening. Sending such an object 1,000 years ago would have been wasted effort. Sending it 1,000 years from now might meet a species already too advanced to be impressed. But to appear now, when our tools are just good enough to notice but not good enough to fully understand, creates maximum intrigue. It dangles the possibility of discovery while ensuring mystery remains. This notion echoes the cosmic breadcrumb theory, that advanced civilizations might seed the galaxy with enigmatic objects, timed to appear when other species reach specific milestones. These objects are not messages in the usual sense, but puzzles, tests, or even invitations. In that view, 3i Atlas arriving now was no accident. It was a breadcrumb left for us to find. The timing also aligns with another troubling possibility: surveillance. If 3i Atlas were a probe, perhaps its mission was to confirm that humanity had reached a level of development worth monitoring. Our use of radio waves, nuclear energy, and spacecraft would all be visible across light years. What better time to send or resend a scout than the moment when a young species begins shouting its presence into the cosmos? Of course, natural explanations abound. Interstellar objects are expected to pass through the solar system regularly. The fact that we are only now noticing them may simply reflect our recent ability to look. The timing might be remarkable only because it highlights our own limitations. But this explanation doesn't erase the unease many feel. Nature doesn't usually provide mysteries at such narratively perfect moments. The philosophical implications of the timing problem ripple outward. If these objects are natural, then perhaps the universe is constantly filled with wanderers, and we've simply been blind to them until now. That suggests a cosmos far more connected, its systems exchanging fragments like messages in bottles drifting between shores. But if the timing is deliberate, if 3 Atlas appeared precisely because we could see it, then humanity may have just passed a threshold into a new kind of cosmic awareness, one where we are no longer merely observers, but participants in a dialogue we don't yet understand. The unease grows when considering what comes next. If the timing of 3i Atlas was orchestrated, does that mean others will follow? Was it merely the opening act in a sequence of encounters designed to escalate as our technology improves? What if the timing was meant to synchronize with events still to come, discoveries in physics, voyages beyond our solar system, or even crises on Earth? For now, the timing problem remains unsolved. Astronomers write papers, philosophers debate meaning, and conspiracy theorists weave stories of secret contact. But the fact remains. In a universe billions of years old, humanity witnessed not one but 2 interstellar visitors within the space of a single decade, just when we had the means to notice them. Coincidence, probability, or something far stranger? The timing leaves us with no clear answers, only the haunting sense that the universe knows when to knock, and that it has chosen to knock now. The echo of Oumuamua. When 3i Atlas was first observed, many astronomers felt a sense of déjà vu. The shape of the mystery, the oddities in its trajectory, the heated debates it triggered, it all seemed eerily familiar. Just 3 years earlier, in 2017, humanity had its first brush with an interstellar object, Oumuamua. That visitor had ignited fierce arguments in the scientific community. Was it a shard of rock, a fragment of ice, or something else entirely? By the time those questions could be asked in earnest, it was already gone. Now, with the sudden arrival of 3i Atlas, the sensation was unmistakable. It was as if the universe had sent an echo. The parallels were impossible to ignore. Both objects appeared from outside the solar system, traveling at speeds too fast to be bound by the sun's gravity. Both displayed strange accelerations that couldn't be easily explained by known physics. And both defied clear classification. They were not quite comets, not quite asteroids, and certainly not anything humanity had encountered before. For many, the resemblance was uncanny, almost staged, as though 3i Atlas was deliberately rhyming with its predecessor, reminding us of the questions we had failed to answer. Oumuamua's story is already legendary. Detected by the Pan-STARRS telescope in Hawaii, it was first classified as a comet, then quickly relabeled an asteroid, and then finally admitted to be something wholly new, an interstellar interloper. Its elongated shape, possibly as long as a football field, its tumbling rotation, and its lack of a cometary tail left scientists baffled. But perhaps the most puzzling detail was its acceleration. As it left the solar system, it sped up in a way that gravity alone could not explain. Some suggested that outgassing from hidden ices might provide the push, but no outgassing was ever observed. Others speculated about more exotic explanations, including the possibility that it was a solar sail or probe. When 3I Atlas arrived, it carried a ghost of those same mysteries. Its trajectory echoed Oumuamua's, as if rehearsing the same strange motions. Like its predecessor, it showed anomalies in speed and reflection. Again, astronomers scrambled to categorize it, and again, no single explanation seemed to fit. The timing between the two, close enough together to be suspicious, yet far enough apart to spark endless debate, made the echo even more pronounced. Some began to wonder whether the two objects were connected. Could they have been fragments of the same larger body, long ago shattered and cast into interstellar space? If so, what massive event could have hurled them across the stars, separated by vast distances yet destined to arrive in our solar system within years of each other? That would imply not only a shared origin, but also a cosmic choreography that seemed almost intentional. The echo also resonated with humanity's response. In both cases, the objects were discovered late, already hurtling away from us by the time they were identified. Telescopes had only days or weeks to gather data before the visitors faded into the darkness. Each left behind a trail of unanswered questions and the lingering frustration that we had not been ready. The repetition of this failure gave the echo a painful edge, as though the universe was telling us we had not learned from the first encounter. Conspiracy-minded thinkers took the echo even further. What if Oumuamua and 3I Atlas were not natural at all, but deliberately sent, staged encounters meant to test humanity's awareness? The first was a shock, a strange shard tumbling past. The second, an echo, was a reminder. If these were scouts, they could be part of a sequence, like a series of knocks at the door. First, one sound to see if anyone is listening, then another, slightly different, to confirm the response. The question that follows is chilling. What comes after the echo? For scientists, the echo raised subtler challenges. If both objects were natural, why were they so similar, yet so different? Oumuamua was long and narrow, possibly cigar-shaped or even disc-like, while 3I Atlas appeared brighter and less consistent in its reflections. If they were siblings, why didn't they look alike? If they weren't, why did their trajectories and mysteries rhyme so well? The echo didn't simplify the puzzle, it doubled it. Even cultural responses mirrored each other. When Oumuamua was discovered, headlines screamed about alien probes and cosmic visitors. When 3I Atlas appeared, the coverage was quieter, as it stood, but the undercurrent of suspicion remained. People remembered the first mystery, and now the second seemed to confirm it. In mythology and folklore, echoes are never meaningless. They signal repetition, cycles, patterns that must be interpreted. To many, 3I Atlas was less a coincidence and more a continuation of a story that had already begun. Ancient traditions spoke of twin omens in the sky. In Babylonian texts, twin comets were considered harbingers of upheaval, arriving together or in sequence to mark the turning of Eris. In Greek myths, the Dioscuri, twin stars Castor and Pollux, were guides to sailors, appearing in storms as a sign of salvation or doom. The echo of Oumuamua through 3 Atlas seemed to fit this archetype. Not a singular event, but a pairing, a dialogue across the void. From a scientific perspective, the echo raised an unsettling possibility. What if interstellar objects like these are far more common than we think? If two were detected within a few years, perhaps countless others have slipped by unseen. That would mean our solar system is not an isolated sanctuary, but a crossroads through which countless wanderers drift. In that light, Oumuamua and 3I Atlas are not anomalies, but emissaries of a larger truth. That the galaxy is alive with fragments, messages, and mysteries, and we are only now beginning to notice them. The echo also carries a warning. Twice now, humanity has failed to prepare. Both visitors were already leaving by the time we realized what they were. We have no probes fast enough to chase them, no infrastructure ready to intercept. If the echo is real, if more are coming, we may not have many more chances to be ready. Each missed opportunity leaves us with silence, speculation, and regret. The repetition forces us to ask, how many echoes will we ignore before we finally listen? Perhaps the most haunting part of the echo is what it implies about intent. If these objects are natural, then the echo is cosmic coincidence, a reminder of the universe's vastness and our own smallness. But if they are not, if they were sent, then the echo is a signal, not of communication in words or images, but of presence. A knock at the door is not a message, it is an announcement. Twice now, the knock has come. Twice now, humanity has heard but not understood. The echo of Oumuamua through Three-Eye Atlas leaves us with a question that is almost unbearable in its simplicity. Will there be a third? If so, will it resemble its predecessors, another fragment of mystery streaking silently through the stars? Or will it break the pattern, bringing answers instead of questions? Until then, we are left with the eerie resonance of repetition. One visitor may be chance. Two begins to look like intention. And in that echo, we hear not only the sound of the past, but the shadow of what may come. The heat that wasn't there. Every object that passes close to the sun should tell the same basic thermal story. Ice heats up and sublimates, rock absorbs radiation and re-emits it as infrared glow, and dust leaves a trail of warmed particles behind. But when astronomers pointed their instruments at 3 Atlas, they found something disturbing. The heat they expected to see simply wasn't there. This mystery began as the object drew close enough to our star for telescopes to track its warming. Comets, for example, reveal themselves by bright tails as frozen gases vaporize into glowing streams. Even dark asteroids radiate measurable heat as they soak up solar energy. But 3 Atlas seemed immune to these rules. It passed into a region where the sun's radiation should have transformed its surface, yet it remained curiously cold and silent. One of the most puzzling aspects was its lack of infrared signature. The Spitzer Space Telescope, designed specifically to detect heat in the cosmos, failed to find the kind of thermal emission astronomers had anticipated. This absence left experts scratching their heads. How could an object traveling so close to a star remain so unresponsive? Was its surface composition unlike anything we'd ever seen? Or was something else at work? The most straightforward explanation proposed was albedo, its reflectivity. If 3-Eye Atlas had an unusually shiny surface, perhaps coated with reflective minerals or ices, it might bounce sunlight away rather than absorb it. But this theory ran into problems. Observations suggested brightness variations inconsistent with a uniformly reflective body. Instead, it flickered strangely, as though parts of its surface alternated between bright and dark. This uneven reflection should still have produced detectable heat. Yet, the heat wasn't there. Another hypothesis was that 3-Eye Atlas was covered in an insulating shell. Imagine an object encased in material that absorbs energy but releases it very slowly, like a cosmic thermos. If true, this might explain why the sun's heat never seemed to penetrate deep enough to produce visible outgassing. Some suggested that layers of carbon-rich compounds or metallic alloys might account for such insulation. But where in the natural universe would an object acquire such a surface? Interstellar space is harsh and chaotic, stripping and eroding most things over millions of years. The idea that 3-Eye Atlas could remain wrapped in an insulating coat defied expectations. Then came the more unsettling possibilities. If the heat wasn't there, perhaps it was being managed. Some astrophysicists entertained the idea, quietly, in speculative papers, that 3-Eye Atlas could be artificial. If an advanced probe wanted to minimize detection, regulating heat would be a top priority. Radiating too much thermal energy would make it visible to telescopes tuned to the infrared spectrum. A ship designed to slip unnoticed through star systems would need to suppress its heat signature, just as stealth aircraft on Earth are built to reduce radar reflections. Could 3-Eye Atlas have been employing the same principle not by chance but by design? Others look backward rather than forward. Was 3-Eye Atlas a fragment of something older, something ancient? If it were debris from a shattered world, its strange thermal behavior might reflect minerals unknown to us, forged in conditions never replicated in our solar system. Imagine a crust of exotic matter, resistant to heat, forged near the heart of a collapsed star. Could 3-Eye Atlas be a shard of that violence, wandering for eons until it drifted into our path? This theory explained its silence, its resistance to heating, and its alien character. But it raised another question. How much of the galaxy is seeded with such remnants, and why did one find us now? The lack of heat also made modeling its trajectory nearly impossible. When comets heat up, Jets of gas act like thrusters, subtly altering their paths. Without heat, there were no visible jets to calculate. Yet 3I Atlas still accelerated slightly in ways no one could fully explain. Heat should have been the cause, but without evidence of warming, astronomers were left staring at equations that no longer balanced. It was as though the universe had rewritten its own rules just to accommodate this visitor. Cultural echoes crept into the discussion. Ancient myths often spoke of cold stars, wanderers in the heavens that gave no warmth and brought omens of misfortune. The Egyptians told of a star god that devoured heat, appearing in the sky as a black sun. The Chinese recorded dark comets that passed without tails, their silence linked to droughts and disasters. To modern ears, these stories sounded poetic, but in the context of 3 Atlas, they suddenly carried an eerie resonance. Had humanity, long before telescopes, glimpsed visitors like this before? Visitors that absorbed light but gave nothing back, leaving only unease? As astronomers debated, the absence of heat forced a deeper philosophical reflection. What if the mystery wasn't about what 3I Atlas was, but about our assumptions of what the universe should be? For centuries, we've relied on the predictability of physics. Objects heat when exposed to stars, they glow, they release, they behave according to models. But 3I Atlas reminded us that the universe is not obligated to conform to our rules. Its coldness was a message, not necessarily sent, but certainly felt, that our understanding is incomplete. Then there was the troubling issue of energy. If 3I Atlas retained its heat, storing rather than releasing it, where did that energy go? Some speculated it could be internalized, perhaps powering unknown processes deep within. Was it a dormant object, slowly charging itself with starlight to awaken later? Was it absorbing solar energy not for display, but for function? If so, its passage near our sun might not have been incidental, but purposeful, a chance to recharge before continuing its journey. The heat that wasn't there remains one of the defining mysteries of 3 Atlas. Long after it vanished into the dark, the absence of its thermal footprint lingers in the scientific record like a missing heartbeat. Natural explanations abound, but none fit comfortably. Exotic ice? Perhaps. Strange minerals? Possibly. But the absence was so complete, so deliberate seeming, that it continues to haunt the conversation. In the end, the silence of heat becomes symbolic. Fire, warmth, and radiation are life signatures, the inevitable consequence of energy interacting with matter. To find an object so close to our sun that refuses to play by those rules is to glimpse something that does not belong, not in the sense of intrusion, but in the sense of strangeness. It is foreign not only to our solar system, but to our expectations of what reality itself permits. 3 Atlas passed, leaving us with no warmth to measure, no glow to chase, only cold equations and colder implications. The heat that wasn't there is more than a missing observation. It is a gap in the fabric of our knowledge, a shadow where there should have been light. And in that shadow lies one of the greatest mysteries of all. What kind of visitor comes so close to the sun, yet refuses to burn? The fragment theory. Among the many attempts to explain the enigma of 3 Atlas, one idea quickly emerged that carried both elegance and unease: the fragment theory. According to this hypothesis, 3I Atlas was not a lone wanderer, not a singular body forged and launched across the galaxy, but a piece of something far larger, something that shattered long ago and cast its remnants into interstellar space. This notion at first seemed simple, but the deeper astronomers pursued it, the more unsettling it became. Fragments tell stories. When asteroids break apart in our solar system, their pieces scatter along predictable orbits, leaving families of related objects that can be traced back to a common parent. Meteorites that fall to Earth bear the mineral fingerprints of their origins, carrying evidence of the worlds that birthed them. If 3 Atlas were a fragment, then somewhere, perhaps far beyond our sight, lies the origin of its story: a parent body destroyed in a violent cosmic event. The first question was obvious. What kind of catastrophe could create a fragment like this? Some speculated that 3I Atlas might be debris from a planetary collision. In young star systems, worlds collide with tremendous energy, their crusts and mantles pulverized into shards. Over millions of years, some fragments might escape their home systems entirely, ejected into the galactic void. If 3I Atlas were such a shard, then we were not witnessing a simple visitor. We were handling the fossil of a dead world. Its strange properties, from its odd acceleration to its inconsistent brightness, could be clues to an alien geology formed under conditions unlike any found in our own solar system. Others suggested something more exotic, that 3I Atlas might be the fragment of a failed star, a piece torn loose during a supernova or stripped away by tidal forces near a black hole. In this scenario, its strange reflectivity and thermal behavior might result from exposure to extremes of heat, radiation, and gravity. Such a fragment would not simply be unusual, it would be unprecedented, a relic of violent astrophysical processes that shaped the galaxy. To hold such an object in our telescopes would be like catching a spark from the forge, where stars themselves are hammered into being. But the fragment theory carried another, darker implication. If 3I Atlas were a fragment, it was not alone. Just as shattered asteroids leave families, so too would a shattered interstellar parent scatter countless siblings across the stars. If one fragment passed us, others could follow, or may already have slipped past unnoticed. This possibility dovetailed uneasily with the earlier visit of Oumuamua. Could the two objects be related? Were they pieces of the same ancient body, separated by vast distances yet still bound by a shared history? If so, then the appearance of both within a few years might not be coincidence at all, but the first whispers of a larger swarm drifting silently through the galaxy. The fragment theory also stirred echoes in ancient myths. Cultures across the world spoke of shattered heavens, of broken stars and celestial shards raining down upon Earth. The Babylonians told of Tiamat, a cosmic body torn apart to form the world, her pieces scattered into the sky. The Greeks spoke of Phaethon, the reckless son of Helios, whose chariot shattered and fell to earth as fragments of fire. Even the Maya recorded stories of sky stones, broken pieces of celestial beings falling from above. These myths may be poetic memories of meteor impacts, but they resonate strangely with the idea that 3I Atlas itself is a shard of some larger unknown whole. Yet the theory does not sit neatly within the bounds of natural explanation. If it were truly a fragment, why did it behave so differently from other debris? Its lack of heat, its unexplained acceleration, its refusal to conform to cometary or asteroidal models, all seem to suggest something more than simple shattered rock. Some scientists whispered that if it was a fragment, perhaps it was not from a natural world at all. What if it were a piece of something engineered, an artifact, a machine, or a vessel long ago broken and abandoned? This speculation drew on another uncomfortable observation. 3 Atlas seemed to lack the irregularity of most fragments. Natural shards are jagged, chaotic, unpredictable. But this object, though mysterious, seemed almost too consistent, too smooth in its anomalies. If it were a fragment, then it might not be a shard of geology, but a shard of technology, a piece of some interstellar craft long ago destroyed. In this framing, 3I Atlas was not simply a relic of nature's violence, but the echo of a lost civilization. The idea that it might be technological debris dovetailed eerily with human anxieties. Our own space programs leave fragments behind. Booster stages, broken satellites, and discarded machinery orbit Earth in clouds of junk. If humanity vanished tomorrow, our fragments would drift through the solar system as mute witnesses to our existence. On an interstellar scale, could other civilizations have done the same? Could 3I Atlas be their equivalent of space debris, an artifact torn loose in some catastrophe, still wandering the stars long after its makers were gone? But if so, how old was it? Interstellar space is harsh, bombarding objects with cosmic radiation and micrometeoroids. Fragments erode over time, pitted and scarred. For 3I Atlas to retain its strange reflectivity and structural integrity, it would need to be made of materials far more resilient than any known to Earth. This realization troubled scientists even more. If it were truly ancient, millions or even billions of years old, then we were looking not just at a fragment, but at a survivor, something designed to endure, drifting silently until chance or fate brought it to our door. There is also the haunting possibility that if 3 Atlas was a fragment, then we saw only the first of many. Its siblings may still be out there, scattered across interstellar space, some perhaps heading our way. Astronomers have already speculated that we are on the cusp of detecting a flood of such objects, now that our instruments are finally sensitive enough. If this is true, then the fragment theory is not just an explanation. It is a warning. The mystery of Three Eye Atlas may soon repeat, multiplied by dozens of other wanderers whose stories we have yet to unravel. The fragment theory leaves us with more questions than answers. What parent body birthed such a fragment? Was it a planet, a star, or something engineered? How many siblings lie scattered across the galaxy, and how many have already passed us unseen? And most chilling of all, if it was a fragment, was it merely debris? Or was it a piece of something still alive, still functioning, still listening? In the silence left behind by Three Atlas, the idea lingers like a shadow. It was not the whole mystery, it was only a fragment of it. And sometimes, fragments are more dangerous than the whole because they hint at something larger, something unseen, and something that may yet come looking for the pieces it lost. The magnetic mystery. When Three Eye Atlas streaked through our solar system, astronomers focused on its trajectory, its shape, and its silence. But beneath those mysteries lay another, quieter puzzle that few outside astrophysical circles fully appreciated: its relationship with magnetic fields. To most observers, it appeared as nothing more than a fast-moving shard of interstellar matter. Yet measurements suggested something unusual, that its spin, its orientation, and even subtle aspects of its motion seemed to listen to forces that ordinary rocks and ice should ignore. This became known as the magnetic mystery. To understand why this is so strange, we must first consider how cosmic bodies normally behave. Comets, asteroids, and fragments of rock are not strongly magnetic. They may contain iron or other metals, but they don't respond to magnetic fields in ways that significantly alter their paths. When such objects move through the solar system, their courses are governed by gravity, and if they are icy, by outgassing jets caused by solar heat. Magnetic effects are negligible, but Three Eye Atlas did not play by those rules. As it tumbled through space, astronomers observed that its rotation behaved oddly. Instead of the chaotic spin expected of an irregular object, its motion suggested influences beyond simple momentum. It was as if something were tugging on it, not gravitationally, but electromagnetically. Subtle shifts in its tumbling hinted that it might be interacting with the interplanetary magnetic field carried outward by the solar wind. If true, this would mean Three Eye Atlas was not just rock and ice, but contained materials, or even structures, capable of coupling with those invisible forces. One explanation proposed that it might contain large deposits of ferromagnetic minerals, such as iron or nickel, left over from its birth in another star system. If so, its passage through solar and interstellar magnetic fields might have nudged its spin, causing the anomalies. But skeptics pointed out that no other comet or asteroid had ever shown such sensitivity, at least not at the scale observed. For this to be the explanation, Three Eye Atlas would need to be unusually rich in magnetic material, more like a cosmic lodestone than a simple shard of rock. Another possibility was even stranger, that it was not merely rich in metal but engineered. Advanced civilizations might construct probes or vessels using conductive or superconductive materials capable of harnessing magnetic fields for navigation. Instead of burning fuel or relying on light pressure, such an object could subtly adjust its course by interacting with the magnetic fabric of space itself. If Three Eye Atlas were such a device, then the magnetic mystery was not a quirk of geology, but evidence of design. Theories like these echo a principle long discussed by futurists: magnetic sails. Just as solar sails use light to propel a spacecraft, magnetic sails, or mag sails, would use giant loops of superconducting wire to interact with stellar winds and magnetic fields. Such a vessel could accelerate, decelerate, or steer without carrying fuel, using the galaxy's natural fields as a highway. If Three Eye Atlas displayed such behavior, then it might not have been a passive fragment at all, but an ancient test of interstellar propulsion. The question that followed was chilling. Was it still functioning, or were we merely observing the corpse of forgotten technology, drifting silently while its systems flickered in and out of life? But even if we strip away speculation about intelligence, the magnetic mystery remains. Astronomers recorded brightness variations that seemed to pulse in odd rhythms, as though parts of the object's surface aligned and misaligned with solar wind activity. These variations did not match the simple, chaotic tumbling of a random rock. Instead, they hinted at some form of resonance. It was almost as if Three Eye Atlas were dancing with the solar magnetic field, moving in harmony with forces invisible to the eye. This behavior reminded some historians of ancient myths. The Chinese spoke of iron stars that fell from heaven, stones that carried strange power and were worshipped as gifts from the gods. In Norse sagas, tales of sky iron linked fallen meteorites with divine hammers and weapons. The magnet stone of Indian lore was said to be a fragment of the heavens that could pull metal toward it. These myths may have been inspired by meteorites, but the uncanny timing of Three-Eye Atlas revived the symbolism. Here, once again, was a stone from the sky that seemed to obey a hidden magnetism. The magnetic mystery also complicates the broader question of origin. If Three-Eye Atlas were simply a natural fragment, where could it have formed such properties? Was it born near a neutron star where magnetic fields are billions of times stronger than anything in our solar system? Did it once orbit a white dwarf or black hole, kind of accumulating scars and materials that gave it these strange sensitivities? If so, then it was not merely a shard of another world, but a messenger from the most extreme regions of the galaxy. There is, however, another angle to the mystery, an unsettling one. If Three-Eye Atlas did respond to magnetic fields, then perhaps its trajectory was not fully natural. What if its path through our solar system was not coincidence, but guidance? A probe using magnetic steering would not follow the predictable arcs of comets or asteroids. It would appear anomalous, its accelerations subtle yet inexplicable. To us, it would look like a natural body behaving strangely. To its makers, it would look like a ship following instructions. The implications are staggering. If we were truly observing the magnetic mystery in action, and then humanity may have witnessed, without fully understanding, a technology far beyond our own. Yet the silence that followed, no signals, no further interaction, suggests either the probe was long dead, or its mission was never meant to announce itself. Instead, it simply passed through, using the sun's magnetism as a stepping stone to continue elsewhere. For scientists, the puzzle remains unresolved. Some papers cautiously argue that the anomalies were observational errors, quirks of limited data collected in a narrow time window. Others insist the data are too consistent to dismiss. Without another chance to observe, the truth lingers out of reach. What makes the magnetic mystery so haunting is not just the lack of answers, but the sense that we glimpsed something we were not yet ready to understand. In the grand tapestry of cosmic puzzles, the magnetic mystery of Three-Eye Atlas weaves together threads of science, myth, and fear. It suggests a visitor that did not merely glide through space but interacted with it, attuned to forces that most rocks ignore. It reminds us of the limits of our knowledge, the possibility of ancient technologies, and the strange harmonies hidden in the universe's unseen fields. And as Three-Eye Atlas fades into the darkness, carrying its secret with it, we are left with the same question that has echoed since its passing. Was it a shard of magnetized rock, a relic of cosmic violence, or a whisper of intelligence hidden in the spin of a fragment that knew how to listen to the stars? The shadow it didn't cast. When an object passes close enough to the sun, its behavior should conform to rules we understand well. It should absorb light, reflect some of it, and cast a shadow, detectable either in the way light dims as it tumbles, or in the contrast of its surface against the void. Yet with Three-Eye Atlas, astronomers faced a riddle that unsettled them more than its trajectory, more than its silence, and more than its speed. It was the mystery of the shadow it didn't cast. Telescopes watching the object expected to see patterns of light and darkness consistent with a body of its size. Even distant asteroids display these rhythms, their spin creating predictable fluctuations as one side reflects more sunlight than another. But the brightness changes of Three-Eye Atlas did not match the geometry of shadows. They were inconsistent, irregular, and in some cases suggested an absence of shadow altogether. It was as though the object reflected light in ways that did not obey the rules of ordinary matter. At first, scientists assumed the irregularities were due to its odd shape. A long shard or flattened disk would tumble and flash in ways that confused sensors. But as data accumulated, the puzzle deepened. Some of its brightness variations were so sharp, so sudden, that they suggested not shadows, but active manipulation of light. Parts of Three-Eye Atlas seemed to flare brightly, while others faded, not in rhythm with its spin, but in ways that implied something stranger, like a surface designed to scatter, redirect, or even absorb light selectively. This anomaly carried profound implications. In physics, shadows are as reliable as gravity. Any solid body blocks light. But if 3I Atlas did not cast shadows as expected, then either its structure was porous and translucent like cosmic glass, or it was wrapped in materials that bent light in unfamiliar ways. Could its surface have been layered with reflective crystals, refracting sunlight as though it were a lens rather than a rock? Or was it covered in substances so dark they swallowed light entirely, erasing the very shadow that should have betrayed them? The latter possibility drew comparisons to vantablack, a material on Earth that absorbs 99.9% of visible light. When applied to objects, it erases their three-dimensionality, making them appear as flat voids. Imagine a body in space cloaked in such material. Its shadow would vanish, its edges would blur, and its true form would become nearly invisible. If 3 Atlas bore such a surface, then its refusal to cast shadows was not a natural quirk, but a clue. It would mean someone, or something, designed it to hide in plain sight. For those unwilling to leap to alien engineering, there remained another explanation: ice and dust scattering light in unusual patterns. Perhaps its surface was coated with exotic ices that sublimated into thin films, creating halos that masked shadows. But even this theory faltered under scrutiny. No tails were seen, no plumes of gas or dust were detected. Without these, the object remained a puzzle wrapped in absence. No tail, no heat, and now no shadow. The strangeness did not end there. Some astronomers noted that the object's albedo, the measure of its reflectivity, seemed to change depending on when and how it was observed. At times, it gleamed brighter than expected, as though it were polished metal. At others, it dulled to near invisibility. The fluctuations didn't align with shadows. They seemed more like signals. Was 3I Atlas broadcasting through light, its surface designed to shimmer and fade in deliberate patterns? If so, the shadow it didn't cast was not an omission, but a message hidden in the void. Across cultures, the absence of shadows has long been a sign of the supernatural. In ancient Egypt, a person's shadow was thought to be part of their soul, its absence a symbol of danger or sorcery. In Greek myth, the shades of the underworld were beings without shadows, wandering in darkness. Japanese folklore tells of yokai that cast no shadows, their inhumanity revealed only by the light they failed to block. Against this backdrop, the behavior of 3I Atlas took on an almost mythical quality. Here was an object from beyond the stars, slipping through our system without casting a proper shadow like the phantoms of old stories. The philosophical implications are equally haunting. Shadows are proof of existence. They are the universe acknowledging an object's presence, marking its interruption of light. To find a body that seemed unwilling or unable to cast shadows was to confront the possibility that it existed differently than ordinary matter. Was it partially transparent? Was it cloaked in a material that bent light around it like primitive cloaking technology? Or was it something we don't even have words for yet, a form of matter whose interaction with photons simply does not align with our physics? Consider, too, the possibility of intention. If 3I Atlas were artificial, its lack of shadow might be the result of deliberate stealth. In interstellar travel, visibility is a liability. Any civilization capable of launching probes across the galaxy would know that light can betray them. Designing a craft to minimize shadows would make it harder to detect, a kind of camouflage against watchful eyes. What we observed, then, may not have been a failure of our instruments, but the success of its design. It wanted to be unseen. But what if the truth lies in between, neither purely natural nor purely artificial? Perhaps 3 Atlas is the relic of something ancient, a fragment of a world where materials formed under conditions alien to us, minerals that absorb rather than reflect, crystals that bend light into silence, a geology we cannot imagine, forged in a star system unlike any we know. In this scenario, the shadow it didn't cast is not evidence of deception, but of difference. The universe reminding us that our assumptions about light and matter are provincial, limited to this one star and its planets. The mystery is compounded by what we didn't record. Instruments that might have captured more detailed shadow dynamics were not in place or not directed at the object in time. Much of the data comes from hurried observations, fleeting glimpses as it slipped away. By the time debates heated, 3I Atlas was gone, leaving behind only hints of the shadow it refused to give us. This absence of evidence becomes part of the story, the echo of what might have been seen had we been prepared. Even now, researchers argue over the data. Some insist the anomalies were the result of observational error, quirks of atmospheric distortion, or limits of our instruments. Others point out that the irregular brightness variations were too consistent to dismiss. The debate itself mirrors the shadow, elusive, hard to pin down, always slipping through the grasp of certainty. The shadow it didn't cast remains one of the most haunting aspects of 3 Atlas. It was not simply a rock from another star, not simply a comet or asteroid. It was something that defied one of the simplest truths of the cosmos, that light reveals form through darkness. By refusing to cast a proper shadow, it became more than a puzzle, it became a symbol. A visitor that existed in defiance of our expectations, a body defined as much by what it withheld as by what it gave. Perhaps that is the final lesson. We look to the heavens expecting light to show us truth, but sometimes it is the missing shadow that speaks loudest. And in the case of 3I Atlas, that silence of darkness remains a question without an answer, a mark not of presence but of absence, lingering long after the visitor itself has vanished. The planetary miss. In a solar system crowded with giants, the odds of a wandering object slipping through unnoticed are astonishingly slim. Planets orbit in sweeping bands, their gravitational wells tugging at anything that passes near. Moons, asteroids, and belts of debris provide countless opportunities for collision or capture. Yet 3 Atlas threaded its way through this cosmic obstacle course with uncanny precision. It avoided Earth, skimmed past Mars, bypassed Jupiter's immense pull, and left the solar system without so much as a scratch. Astronomers could not help but marvel at the improbability of its journey. How did it miss every planetary body? Was it luck or was it something else entirely? The statistics alone are mind-bending. Our solar system stretches vast distances, but its gravitational zones of influence are immense. Jupiter, in particular, acts like a gatekeeper, pulling countless comets into altered orbits or swallowing them outright. For 3I Atlas to arrive on a trajectory that threaded between the giants without a single close encounter was like shooting an arrow across a battlefield and watching it pass unscathed between 1,000 spinning blades. Even a slight deviation could have pulled it into a collision or permanent orbit. Yet, the path it chose, or was given, ensured escape. Some scientists explain this as mere probability. After all, interstellar space is vast. An object entering from beyond may have any number of trajectories, most of which bypass planets simply because the planets occupy so little of the available space. But others countered that this neat dismissal ignored the fine details. 3I Atlas didn't just miss planets, it missed them narrowly, threading gaps so small they felt almost intentional. Its closest approaches aligned in ways that suggested not random drift, but deliberate precision. This led to the uncomfortable question, was its path guided? If 3I Atlas were a natural fragment, its course should have been chaotic, nudged by tiny forces, deflected by gravitational pulls, yet its escape trajectory seemed clean, almost surgical. That precision made some researchers wonder whether the object had adjusted itself using mechanisms invisible to us. Could it have steered just enough to avoid planetary entanglement? And if so, why? To ensure its survival, or to ensure observation without interference? The planetary miss also echoed a pattern in ancient records. Cultures around the world spoke of sky wanderers that came close to Earth but never struck. In Mesopotamian texts, celestial omens were often described as stars that brushed the heavens yet passed on. The Greeks wrote of comets that touched but did not fall, harbingers of change. Even Mayan glyphs depict stars skimming Earth's path, narrowly missing catastrophe. To ancient eyes, these misses were divine restraint, the gods sparing humanity. To modern astronomers, 3I Atlas's planetary miss was not divine but mathematical, though no less unsettling for its precision. Then there is the matter of energy. A planetary collision, or even a near pass, could have slowed or trapped 3I Atlas. Instead, it escaped the solar system with excess velocity, as though it had always intended to pass through rather than stay. This again raised suspicions of purpose. If it were a probe, then a mission requiring survival would demand a careful trajectory, one that avoided planetary bodies. In that scenario, the planetary miss was not improbable luck, but the success of a plan. Some proposed a different but equally unsettling theory: gravitational surfing. An advanced object might deliberately use planetary fields to adjust its course while avoiding capture. By skimming just outside the influence of worlds like Jupiter, it could slingshot toward its next destination without ever risking collision. From Earth's perspective, this would look like a miraculous planetary miss. From the object's perspective, it would be navigation. Of course, the natural explanations remain. Probability alone might account for its clean passage. The solar system, despite its planets, is mostly empty space. Countless comets have passed through without striking anything, but the unease lingers because of the timing. Oumuamua had passed just 3 years earlier, equally unscathed. Two interstellar objects in rapid succession, both threading the solar system without a planetary encounter? That felt less like randomness and more like choreography. The planetary miss also highlights our vulnerability. Had 3I Atlas been on a slightly different course, Earth might have faced a catastrophic encounter. Even a fragmentary impact could have unleashed devastation on a global scale. Yet we had no warning, no way to deflect it, no plan beyond watching. That it missed us may be a matter of cosmic fortune. Or perhaps, if one entertains darker ideas, it was never intended to strike, only to pass close enough to be seen, close enough to remind us of our fragility. This thought casts the planetary miss as a kind of cosmic signal, a warning shot that never landed, the universe showing us its power without exercising it. Humanity, for all its arrogance, remains at the mercy of wanderers from the void. Each miss carries with it the weight of inevitability. One day, one will not miss. And the difference between chance and catastrophe is measured in fractions of degrees, tiny adjustments across the expanse of space. There is another angle as well, one of invisibility. If 3 Atlas had struck a planet, we would have studied its remains, measured its composition, and perhaps solved its mysteries. But by missing, it denied us evidence. It allowed us only fleeting glimpses, brief data, and endless speculation. The planetary miss preserved its secrets, keeping it intact as it slipped back into interstellar night. Perhaps this too was its purpose, to be seen but not caught. Philosophically, the planetary miss embodies the essence of mystery itself. It is an event defined not by what happened, but by what didn't. No collisions, no captures, no fiery endings. Only absence, an object that could have changed the course of worlds, yet chose not to. It reminds us that sometimes the most profound events are those that pass us by, leaving us with questions rather than scars. Even now, astronomers debate its meaning. Was the miss nothing more than statistics? Or was it a carefully tuned path, the signature of intention? Natural or artificial, fragment or probe, 3 Atlas left us with the haunting image of a visitor that brushed against the vast machinery of planets and escaped untouched. In the end, the planetary miss may be the most human of its mysteries, for it forces us to confront our place in the cosmos, not as masters of destiny, but as watchers, lucky bystanders to a game played on scales we cannot control. 3 Atlas passed us by, leaving Earth unscathed, and in doing so reminded us of both our survival and our smallness. It was not the strike that shook us, but the miss. And in that empty space between what could have been and what was, we find a question that lingers. Was it luck, or was it design? And if design, then who or what guided the arrow past the planets and into the endless dark beyond? The artificial rotation? When astronomers first measured the tumbling of 3I Atlas, they expected chaos. Natural fragments from interstellar space, battered by radiation and collisions over millions of years, usually spin irregularly. Their rotations wobble, slow, or accelerate unpredictably as uneven surfaces catch sunlight or outgassing jets act like thrusters. But 3I Atlas refused to conform to those expectations. Its rotation, while strange, bore qualities that seemed almost too precise, too consistent. That precision sparked one of the most controversial questions of all. Was its rotation artificial? At first glance, the object's movement appeared to be a complex tumble, as though it were cartwheeling through space rather than smoothly spinning. But detailed analysis revealed patterns hidden within the motion. Instead of the random distribution expected from a jagged rock, its spin showed recurring intervals, as though its body were balanced in subtle ways. This balance suggested either a surface geometry unlike any asteroid we know, or some internal mechanism regulating its spin. For natural objects, balance is rare. For engineered machines, it is essential. The case grew stranger when brightness measurements were compared with its rotational data. The object flickered with peculiar rhythms, sharp changes in light intensity, followed by stretches of stability. Astronomers assumed these were caused by reflective surfaces coming into view as it spun. Yet the timing of those flashes did not perfectly match predictions based on a chaotic tumble. Instead, they hinted at deliberate modulation, as if its spin had been tuned to present certain surfaces toward the sun and others away. A body that rotates in such a controlled fashion ceases to look random. It begins to look intentional. This raised the unsettling possibility of stabilization. On Earth, engineers designed satellites with spin stabilization systems, allowing them to maintain orientation without expending much fuel. Some use reaction wheels, others gyroscopic motion, and still others magnetorquers, devices that interact with Earth's magnetic field. Could 3 Atlas have employed something similar? If so, then its spin was not an accident of physics, but the result of engineering, a clue that the object was more than just a shard of rock. Skeptics countered with naturalistic explanations. Perhaps the rotation was simply the result of collisions in its distant past, set spinning by an impact millions of years ago, or perhaps uneven heating from the sun created the Yarkovsky-O'Keefe-Radzievsky-Paddock effect, a process where light and heat push on small surfaces, slowly altering rotation. But these explanations faltered when compared to the data. The observed consistency was difficult to square with random impacts or uneven heating. Instead, it resembled a system that was not merely spinning but maintaining spin. This idea that its rotation could be regulated echoed ancient stories of stars and objects in the sky that moved with intent. Chinese records spoke of heavenly wheels that turned evenly, guiding emperors' fates. The Greeks described spheres of the cosmos rotating not chaotically, but with divine regularity. To them, motion itself was proof of design. Thousands of years later, staring at 3I Atlas, modern astronomers found themselves haunted by the same suspicion, movement that looked purposeful. The artificial rotation theory also raised questions about function. If it were a probe or vessel, what purpose would a stabilized spin serve? One answer lay in communication. A rotating body with reflective surfaces could use its spin to modulate signals, flashing light in patterns that distant observers might detect. In that scenario, the strange rhythms of brightness were not coincidences, but codes, beamed into space as the object journeyed onward. Another answer lay in durability. A stabilized spin would help a craft endure the stresses of interstellar travel, distributing forces evenly rather than letting them tear it apart. But the most compelling possibility was energy. A spin-regulated body could maintain solar exposure on certain surfaces, perhaps to charge itself, while shielding other surfaces from radiation. If 3I Atlas were artificial, its rotation may have been its survival mechanism, keeping it alive as it drifted between stars. And yet the idea of artificiality provokes dread as much as wonder. If it spun by design, then who or what designed it? Was it the fragment of a probe, still functioning after millions of years? Was it a derelict, its systems decayed, but its rotations still echoing the purpose of its makers? Or was it something else entirely? A monument, a marker, or even a warning, cast adrift to remind younger civilizations that they are not alone. The artificial rotation hypothesis also casts new light on its predecessor, Oumuamua. That object, too, spun in baffling ways, end over end, elongated and unstable, yet oddly consistent. Taken together, both objects hint at a pattern, not random rocks, but tuned devices. Was 3I Atlas the echo of Oumuamua, repeating the same controlled motions to reinforce a message? If so, then the question is no longer whether they are natural, but whether we are willing to acknowledge the signs of design. Some scientists, reluctant to embrace extraterrestrial explanations, suggested that we simply lack enough data to be sure. Indeed, most of our observations were rushed, gathered in the brief window before 3I Atlas vanished into darkness. Perhaps, they argue, the illusion of artificiality is just a trick of incomplete information. But the opposite is also true. Perhaps our inability to collect more data was itself part of the design. A probe meant to remain mysterious would never linger long enough for full analysis. It would spin just enough to be seen, then vanish. The cultural weight of the artificial rotation theory cannot be overstated. Humanity has always looked to the skies for signs of intelligence beyond our own. From the first radio signals to modern exoplanet surveys, we have strained to hear voices across the void. What if the first reply was not a voice at all, but a movement? A rotation too precise to be chance. In that case, 3 Atlas was not a message in words, but a demonstration in physics, a reminder that meaning can be written in motion. There is also a darker interpretation. What if the rotation was not meant for us at all? What if it was part of its function, irrelevant to human eyes? A probe passing through countless systems would need to regulate itself regardless of who was watching. In that view, we were never its audience. We were bystanders, catching a glimpse of something that had nothing to do with us. The thought is humbling and terrifying. For it implies that intelligence greater than ours is already active in the galaxy, indifferent to our awareness. The artificial rotation of 3I Atlas remains an open question, unresolved and perhaps unresolvable. It may have been coincidence, a quirk of physics, or the illusion of pattern-seeking minds. Or it may have been the faint echo of engineering, a mechanical heartbeat from beyond the stars. As it slipped away, spinning in its peculiar rhythm, humanity was left with a choice. Do we dismiss its motion as accident, closing our eyes to the possibility of design? Or do we admit that in the quiet tumble of a distant fragment, we may have witnessed intent? 3I Atlas is gone now, beyond the reach of our telescopes. Its spin continues in silence, hidden in the vast dark. But the question it left behind lingers like an echo in the human imagination. Was it turning because the universe made it so, or because someone, somewhere wanted it to? The lost recordings. Every great mystery leaves behind not only questions, but also fragments of evidence, scraps of data that future generations can analyze. Yet when it comes to 3I Atlas, a chilling rumor persists among astronomers and enthusiasts alike. Much of what was observed has been lost. The story of the lost recordings has become one of the most enduring subplots of this interstellar visitor, an absence that may be more haunting than the object itself. The initial discovery of 3I Atlas was hurried, almost frantic. Sky surveys designed to detect near-Earth asteroids flagged the anomaly, and telescopes across the world turned to capture it. But in the chaotic scramble of observation, data collection was inconsistent. Clouds, mechanical failures, and limited observation windows meant that only a fraction of the possible recordings were made. What's worse, several key instruments that should have provided crucial information either failed or reported incomplete results. Consider the Spitzer Space Telescope, an infrared observatory capable of detecting heat signatures. For reasons never fully explained, its observations of 3I Atlas came back empty. No thermal emissions, no useful data. Was this failure technical, or was it a reflection of the object's unnatural coldness? Either way, the missing heat maps became one of the first lost recordings of the mystery. Without them, scientists were left with guesses where certainty might have been possible. Then came the case of the ground-based telescopes. Several observatories reported capturing unusual brightness variations, flickers and pulses that hinted at complex rotation or even deliberate modulation. Yet many of those raw recordings were never released in full. Some were corrupted. Others were archived improperly, vanishing into digital vaults never to resurface. A few were allegedly erased, dismissed as instrumental noise. To conspiracy theorists, this was evidence of deliberate suppression. To cautious scientists, it was simply the tragic reality of limited resources. But to anyone searching for answers, it was maddening. The most puzzling object humanity had ever seen had left behind a trail of broken, missing, or inaccessible files. Radio telescopes also entered the story. When Oumuamua passed in 2017, SETI programs listened for possible signals, hoping to catch whispers of intelligence. With 3I Atlas, the same effort was made. Arrays like Green Bank and Breakthrough Listen reportedly aimed their ears at the visitor, yet no clear results were ever published. Were the recordings silent, or were they inconclusive? Rumors persist that faint anomalies were detected, strange bursts buried in noise, but that they were deemed too uncertain to announce. Whether true or not, The absence of transparent data left fertile ground for speculation. The radio silence became not just the object's silence, but humanity's silence too. The most tantalizing whispers come from amateur astronomers. Independent skywatchers with backyard telescopes claim to have recorded strange light curves, sequences of flickers too regular to be random. Yet when pressed for their files, many reported malfunctions, crashes, or inexplicable data corruption. Entire nights of recordings vanished from hard drives. Some blamed faulty equipment. Others hinted at hacking, as though someone or something did not want those recordings preserved. These stories may be exaggerations born of frustration, but they contribute to the growing mythology of the lost recordings. The phenomenon of missing data is not new. Throughout history, significant celestial events have often been poorly documented. The Tunguska explosion of 1908 left almost no photographic evidence, despite occurring in the age of cameras. The first radio signals from pulsars were nearly dismissed as interference. But with 3I Atlas, the lost evidence feels deliberate, almost scripted. The object appeared suddenly, defied explanation, and then disappeared, taking with it much of the proof of its existence. What we have left are partial glimpses, fragments of recordings, and the uneasy knowledge that more should have been preserved. Cultural interpretations of missing evidence only deepen the mystery. Ancient texts often describe heavenly signs that were seen briefly and then erased. In Mesopotamian lore, the star that vanishes was considered an omen of hidden truths, events that would remain sealed until their appointed time. In medieval Europe, chroniclers sometimes wrote of celestial phenomena struck from the record by fearful scribes. Even in modern UFO lore, the pattern repeats: blurry photos, corrupted tapes, missing reels. The story of 3I Atlas fits neatly into this tradition, as though the cosmos itself ensures that its greatest mysteries slip through our fingers. But what if the lost recordings are not accidents of human failure, but artifacts of the object itself? Imagine an interstellar probe designed not to be studied. It could emit bursts of electromagnetic interference, disrupting instruments aimed at it. It could scatter light in confusing ways, corrupting optical data. It might even generate false signals, ensuring that attempts to capture its essence result only in noise. In that scenario, the missing data is not evidence lost, it is evidence concealed, a deliberate obfuscation by something that wanted to pass unnoticed. Another possibility is more mundane but no less disturbing: bureaucracy. Observatories are funded by grants, guided by priorities, and often overwhelmed by competing demands. By the time astronomers realized the significance of 3I Atlas, it was already slipping away. Files sat unanalyzed, servers filled, priorities shifted. In the shuffle, critical data was misplaced. The loss, then, is not cosmic but human, a reminder that our systems are not ready to handle the unknown when it arrives. For those who lean toward the conspiratorial, the lost recordings are damning. They suggest that more was seen than has been admitted, that governments or agencies quietly seized the data, fearing the implications of disclosure. A controlled leak here, a corrupted file there, all to maintain a fragile silence. If true, then the mystery of 3 Atlas is not only about what it was, but about what we were not allowed to know. The lost recordings also speak to the fragility of human knowledge. In an age of digital abundance, we imagine that everything is preserved. But data is fragile, subject to corruption, obsolescence, or neglect. Future generations may look back on the 21st century and see not an era of great discovery, but an era of vanished opportunities, moments when the universe revealed itself, only for humanity to misplace the evidence. 3 Atlas may be remembered not only for what it was, but for what we failed to keep. And yet, the absence itself has power. The missing files, the corrupted images, the unshared radio recordings, they fuel imagination more than perfect clarity ever could. The gaps invite speculation, creativity, and unease. Perhaps that is why the lost recordings matter so much. They turn 3 Atlas from an astronomical curiosity into a legend. Like whispered stories of vanished scrolls, burned libraries, or lost gospels, they transform a scientific puzzle into a myth of absence. In the end, the mystery of the lost recordings is inseparable from the mystery of 3 Atlas itself. Both appeared suddenly, offered glimpses of strangeness, and then vanished, leaving silence where answers should have been. Perhaps one day a hidden archive will surface, revealing data long forgotten, Perhaps another interstellar visitor will arrive, giving us a second chance. Until then, the lost recordings remain a void, a silence within a silence, a shadow within a shadow. And maybe that is the truest echo of 3 Atlas. Not what we saw, but what we didn't. Not the data we captured, but the data that slipped away, leaving us to wonder whether the most important recordings of our time were not erased by accident, but erased by design. The Interstellar Highway. When astronomers plotted the path of 3I Atlas, something curious emerged. Its trajectory, while unusual, was not chaotic. Instead, it moved with a kind of smooth inevitability, threading through our solar system on a line so clean it seemed preordained. To most, it was simply an interstellar object obeying gravity. But to others, the thought began to creep in. What if 3I Atlas wasn't just wandering randomly? What if it was following a route, an interstellar highway laid out not by chance, but by the very structure of the galaxy? The idea of interstellar highways is not new. Physicists and mathematicians have long known that the universe is crisscrossed with invisible pathways shaped by gravity. Every planet, moon, and star warps space around it, creating regions where a traveler might fall from one orbit into another with minimal energy. These gravitational corridors are sometimes called the interplanetary transport network, highways of almost zero energy that spacecraft can ride like currents in the sea. We've used them before. NASA's Genesis probe, for example, drifted along one of these routes to capture particles of solar wind. If we, with our fledgling technology, can use these highways, why not others? When mapped across the solar system, these gravitational corridors form an intricate lattice of entry and exit points, gateways between planetary orbits, woven by the pull of the sun and its planets. An object falling into one of these gateways can be carried along its path with little or no propulsion. To the untrained eye, such motion looks improbable, almost miraculous, a body slipping past planets and moons as if guided by invisible hands. But to those who know the math, it is navigation. The trajectory of 3I Atlas bore striking similarities to these routes. Its course carried it past regions of gravitational influence in ways that seemed almost too efficient, as though it were surfing the invisible highways that connect one part of space to another. It did not collide, it did not linger. It simply moved, smoothly, deliberately, and with precision. Was this coincidence? Or was 3I Atlas making use of highways we have only just begun to understand? If so, then it changes everything. Instead of being a random visitor, 3I Atlas could be one of many travelers gliding along ancient lanes of motion, its passage determined not by luck but by the architecture of the cosmos. Like ships carried by ocean currents long before humans learned to map them, interstellar objects might drift along routes carved by gravity itself. To us, these highways are invisible. To them, they are the roads of the universe. But then comes the unsettling twist. What if these highways are not only natural? What if someone, somewhere, has learned not only to use them, but to refine them? An advanced civilization might seed certain regions of space with stations or devices to mark, stabilize, or even manipulate these routes. The galaxy could be threaded with ancient lanes of travel, designed not by physics alone, but by intention. In that view, 3I Atlas was not simply a rock riding the tide of gravity. It was a traveler on a road we cannot yet see. This possibility recalls ancient myths of celestial roads. In Mesopotamian lore, the gods traveled along the path of Enlil, a cosmic highway across the heavens. The Norse spoke of Bifrost, the rainbow bridge linking worlds. The Incas believed in a celestial river that guided spirits through the sky. In every culture, there are echoes of roads across the stars, paths that connect the seen and unseen, the mortal and the divine. Could those myths have been inspired by glimpses of the same truth we now suspect, that the cosmos is woven with highways no less real than the roads of Earth? The interstellar highway theory also reframes the mystery of Oumuamua, 3 Atlas's famous predecessor. Its path, too, bore the hallmarks of efficiency, slipping through the solar system without collision and leaving just as smoothly. 2 visitors, within years of each other, both appearing to follow invisible roads. Was this mere chance? Or was it evidence of a greater pattern, a traffic of wanderers passing along lanes of the galaxy with Earth's solar system as one of many waypoints? This idea unsettles because it implies frequency. If these highways exist, then 3i Atlas was not unique. Countless other objects, natural or artificial, may already have traveled the same route, unnoticed in ages before we had the instruments to see them. We may not be special. We may simply live near an interstellar road, our skies crossed by silent travelers who rarely stop. And yet, the precision of 3i Atlas's passage raises another possibility. What if it was not merely drifting, but steering? To ride an interstellar highway, small adjustments are necessary, nudges to stay within the corridor. Without those nudges, an object would drift away. Natural bodies, unless perfectly aligned, would rarely maintain such clean courses. Artificial probes, however, could. If 3i Atlas was steering, then it wasn't just a traveler on a highway, it was a driver, choosing its route. That possibility is haunting. It means 3i Atlas may not have been the first we've seen, but the first we noticed. Others may have come and gone, invisible in our ignorance, following the same roads with quiet regularity. And if they are probes, then perhaps the highways are not just routes of convenience, but routes of surveillance, laid out long ago to monitor worlds like ours. Philosophically, the interstellar highway speaks to a deeper truth, that the universe is not empty chaos, but patterned order. Just as rivers carve valleys, gravity carves lanes across the stars. And just as ancient sailors learned to read the currents and winds, so too may civilizations across the galaxy have learned to read and ride these invisible flows. In that light, 3i Atlas was less an intruder and more a messenger, not because it sent signals, but because it revealed the road beneath our feet. Yet the mystery remains. Was it natural, or was it guided? Was it a shard of stone carried by forces it did not control, or was it a vessel that knew exactly where it was going? The data cannot tell us. What it does tell us is that its path was efficient, improbably so, and that it left the solar system with the same smoothness with which it entered, like a traveler passing through a crossroads without pausing. The interstellar highway is not just a scientific theory. It is a metaphor for our moment. Humanity stands on the edge of awareness, just beginning to see the invisible roads of the cosmos. We have built ships that can drift along them, but we do not yet understand their full scope. 3i Atlas passed us by, reminding us that we are not alone on these highways. Other travelers, natural or not, share them. Some may have passed long before us. Others may come again. And so, we are left with a haunting image, our solar system, a lonely rest stop on an interstellar road. Travelers pass, sometimes noticed, often not. Some may be shards of broken worlds, others probes or vessels of civilizations older than ours. 3i Atlas was one such traveler, a fleeting glimpse of traffic on the great highways of the galaxy. It left no message, no landing, no answers. Only the road itself, invisible and silent, and the memory of a stranger who rode it well. The absence of dust. One of the most striking mysteries of 3i Atlas was not what it revealed, but what it withheld. Nearly every object of its kind, comets, asteroids, icy wanderers, carries with it a halo of dust, the scattered remnants of its structure shaken loose by radiation and solar winds. Yet when astronomers turned their instruments toward 3i Atlas, they found nothing. No shimmering dust trail, no glowing coma, no debris scattered behind it like breadcrumbs. It passed through the solar system as if it had been polished clean. This absence of dust became one of the most baffling anomalies of all. Dust is not a trivial matter in astronomy. It is the key by which scientists decode the composition of celestial bodies. When comets heat up near the sun, dust erupts alongside gases, revealing the ingredients of their icy cores. Asteroids, battered by micrometeoroids, shed faint clouds of particles that linger in their wake. Even interstellar space is rich with dust grains, tiny fragments of carbon, silicates, and metals that accumulate over eons. For an object like 3i Atlas to appear entirely dustless defied expectations. It was as though it had scrubbed itself of every particle that could betray its nature. At first, astronomers proposed practical explanations. Perhaps it was composed of unusually dense material, resistant to fragmentation. A shard of solid rock, forged under extreme pressures, might leave no trail behind. But this theory faltered when considering its acceleration anomalies. If it were solid rock, how did it speed up as though pushed by unseen forces? Another suggestion was that it had already exhausted its dust in some prior encounter with a star, leaving behind a barren husk. But interstellar journeys are harsh, filled with cosmic rays and collisions that should create not erase debris. For 3I Atlas to be dustless, even after millions of years of travel, made little sense. The absence of dust also affected how it appeared in telescopes. Normally, a dusty object grows brighter as sunlight scatters across its halo, but 3I Atlas flickered unpredictably, without the smooth glow that dust would provide. Its reflection seemed too sharp, too naked, as if we were seeing the surface itself rather than a softened veil of particles. This made it harder to classify, leaving scientists arguing over whether it was comet-like, asteroid-like, or something entirely new. Without dust, there was no easy answer. Then came the more speculative theories. Some researchers suggested that 3I Atlas might be coated in an insulating crust, carbonized material hardened into a shell that prevented dust from escaping. But others took a bolder leap. What if the absence of dust was intentional? If 3I Atlas were artificial, designed as a probe or vessel, its makers would want it to remain clean, free of trailing debris that could draw attention. Dust is detectable across vast distances. A true scout would travel without it, leaving no signature in its wake. This idea struck a chord with those who already suspected that 3I Atlas and its predecessor, Oumuamua, were not merely natural wanderers, but visitors with purpose. Oumuamua had shown faint signs of outgassing without dust, already an anomaly. But 3I Atlas carried that strangeness further, behaving as if it had deliberately erased all evidence of its passage. In a universe where dust is inevitable, its absence was louder than any trail could have been. Mythology offers haunting parallels. In ancient cultures, dust often symbolized mortality and decay, ashes to ashes, dust to dust. To move without dust was to move without corruption, without the signature of time. The Egyptians spoke of gods who crossed the heavens leaving no trail. The Greeks told of divine chariots that rode through the sky without scattering sparks. In Mayan glyphs, celestial wanderers were depicted as clean, perfect orbs, contrasted with comets whose tails symbolized chaos. Across civilizations, beings that left no dust were not natural, they were otherworldly. Scientifically, the absence of dust left us blind. Dust carries chemical fingerprints, clues about whether an object formed around a young star or in the cold reaches of interstellar space. Without it, astronomers could not determine whether 3I Atlas was icy, rocky, or metallic. Its very composition remained a mystery, hidden behind the silence of its clean path. This silence frustrated researchers, but it also fueled wonder. Perhaps we had glimpsed not just a new kind of body, but a new category of existence. There is also the possibility of resilience. If 3I Atlas were forged in an environment of extreme heat or pressure, its materials might be so tightly bound that dust simply could not form. Such an object would be nearly indestructible, hardened against cosmic radiation, micrometeoroid impacts, and stellar winds. If true, it was not just clean, but immortal, gliding through the galaxy unchanged while lesser bodies crumbled around it. That resilience would make it an ideal candidate for interstellar travel, natural or artificial. Another possibility lies in its interaction with light. Some speculated that 3I Atlas might not have lacked dust, but rather concealed it through unusual optical properties. Its dust, if present, might have been dark beyond our instrument's sensitivity, absorbing light rather than scattering it. A trail of invisible particles undetectable to human eyes could still exist. But if so, what kind of matter was it composed of? Dark carbon, exotic silicates, or something truly alien? Dust not of this solar system and not of this chemistry. The absence of dust also had practical consequences. Dust is what allows us to track faint objects over time. Without it, 3I Atlas was harder to detect, harder to measure, and easier to lose. By the time debates reached their peak, it was already fading into the dark. The very feature that made it strange also ensured its secrecy. Without dust, it remained invisible to many instruments, slipping away before humanity could understand it. This raises an unsettling thought. How many others have we missed? If 3 Atlas was dustless, perhaps countless other interstellar objects have passed undetected, invisible in their cleanliness. Our surveys are tuned to spot glowing tails and bright halos. A body without them is nearly invisible until it is already upon us. 3 Atlas may not have been the first. It was only the first we saw. The absence of dust forces us to confront the limits of our perception. We rely on the expected to find the unexpected. But when the universe offers us something outside those expectations, an object that refuses to scatter, refuses to decay, refuses to leave traces. We are left blind. Dust, the language of comets and asteroids, was silent here. And in that silence, 3 Atlas became something beyond our categories. Whether natural or artificial, its cleanliness was unnerving. If natural, it was forged in an environment so alien that it challenges our understanding of planetary formation. If artificial, it was crafted with intent, a design that ensured secrecy. In either case, it left behind not the clutter of dust, but the sharper, lonelier mystery of a visitor who passed without leaving footprints. In the end, the absence of dust is less about what we saw than about what we didn't. A body that should have shed itself like all others instead remained pristine, silent, and inscrutable. Its path through our solar system was marked not by the glittering debris of a comet, but by emptiness. And sometimes emptiness speaks the loudest of all. 3I Atlas came and went without a trail. No dust, no debris, no answers. Just the memory of a clean traveler gliding through the crowded highways of our system, vanishing into the dark with its secrets intact. And we are left with the echo of absence, the haunting knowledge that sometimes the greatest mysteries are not in what lingers behind, but in what is missing altogether. The brightness puzzle. When astronomers first locked their instruments onto 3I Atlas, they expected its light to behave in ways that matched their models of asteroids and comets. These celestial bodies, as they tumble through space, brighten and dim in predictable rhythms, the sunlight reflecting off their uneven surfaces. Yet the light curve of 3I Atlas did not tell a predictable story. Instead, it flickered with strange irregularities, pulsing like a heartbeat that refused to match the steady cadence of natural rotation. This enigma became known as the brightness puzzle, one of the most confounding mysteries the object carried with it on its fleeting visit. At times, 3 Atlas shone more brightly than expected, as though some surface had caught the sun like a mirror. Moments later, it would fade to near invisibility, as if its body had swallowed the light whole. These changes were not smooth arcs, but abrupt spikes, as though the object itself were signaling. For astronomers accustomed to explaining brightness with rotation and surface texture, the data made little sense. It was as if 3 Atlas were not merely reflecting light, but modulating it. The puzzle deepened when comparisons were made with its infamous predecessor, Oumuamua. That first interstellar visitor had also shown odd fluctuations in brightness, leading to debates over its shape. Was it a cigar-like shard or a pancake-like disk? The variations were too sharp to belong to ordinary geometry. Now, with 3I Atlas, the same anomaly returned. 2 objects, separated by time but united in strangeness, both displayed light curves that defied conventional explanation. Was this coincidence or a pattern? Some scientists argued that the puzzle could be solved by shape alone. Perhaps 3I Atlas was extraordinarily elongated, like a splinter of cosmic glass, spinning end over end. In such a case, sunlight might flash dramatically as its long axis came into view. But this theory struggled under scrutiny. The intensity of its brightness shifts suggested reflective properties far greater than ordinary rock. At times, it gleamed almost like polished metal. No known natural body reflects sunlight with such precision. Another theory proposed a surface coated with volatile ices, glistening like frost. As it rotated, these patches could produce sudden bursts of brightness, shimmering as they vaporized under solar heat. Yet no accompanying cometary tail was observed, no halo of dust or gas. The flashes came without evidence of outgassing. The brightness was there, but its cause remained invisible. This led some to speculate about more exotic possibilities. Could the fluctuations have been artificial? If 3I Atlas were a probe or fragment of technology, its surface might include panels or structures that reflected light deliberately. In this scenario, the flickers were not accidents, but patterns, signals encoded in the play of sunlight. The idea of optical beacons has long been suggested by SETI researchers, using reflected starlight as a way to communicate across vast distances. Could 3I Atlas have been doing just that? If so, we may have missed the message, mistaking its light for randomness. The brightness puzzle was not only scientific, but philosophical. Light is how we see the universe. Every star, every planet, every comet, we know them by the photons they cast our way. For an object to manipulate that light in ways we cannot explain is to challenge our most basic assumptions about observation itself. Was 3i Atlas hiding something in those flickers? Or was it showing us something we lacked the language to understand? History is filled with tales of mysterious lights in the sky. The Romans recorded stars that blinked, appearing and vanishing like flames. Medieval chronicles describe comets that pulsed in brightness, heralding plagues or wars. Indigenous peoples spoke of sky fires that flashed messages from spirits. In each case, the lights were interpreted as omens. Now, with 3i Atlas, modern science encountered a similar omen, not divine, but deeply unsettling. An object from beyond the stars, flickering as if alive. Some suggested resonance with the sun's radiation. Perhaps the brightness shifts came not from reflection but from interaction, an unusual surface material absorbing and releasing energy in bursts. This could explain the suddenness of the changes, though no known material behaves in such a way across the observed spectrum. Others wondered if 3i Atlas carried cavities or hollows that acted like mirrors, focusing and scattering light in unpredictable ways. Yet this, too, felt unsatisfactory. For the changes were not merely unpredictable, they were rhythmic, hauntingly so, like the beat of a drum heard through walls. The brightness puzzle also highlighted the limits of our technology. Telescopes captured fragments of its light curve, but never enough to build a complete picture. Observations came from different locations, under different atmospheric conditions, with instruments that were often already occupied with other missions. By the time a coordinated effort could be mounted, 3i Atlas was gone. The puzzle remained unsolved, not because answers weren't possible, but because the opportunity had already slipped away. For some, this loss became symbolic. The universe had handed us a riddle, written in light, and we failed to read it. It reminded us of humanity's fragile readiness, how little we are prepared for sudden encounters with the unknown. If 3 Atlas was a messenger, then its message was silence, delivered in flickers we could not decode. The brightness puzzle also carried with it a warning about perception. Human eyes are drawn to patterns, and sometimes we see design where none exists. Could the flickers have been nothing more than coincidence, amplified by our hunger for meaning? Or did we dismiss too quickly the possibility that they were deliberate, fearing what that would imply? Between skepticism and wonder, the puzzle sits uneasily, neither fully natural nor fully artificial, but something in between. Philosophically, the brightness puzzle touches on one of the oldest questions of science and myth alike. How do we know when we are being watched? Light is both a tool and a trap. It reveals, but it also conceals. If 3 Atlas wanted to be noticed, flickering was the simplest way. If it wanted to confuse us, flickering was also the simplest way. Either way, the effect was the same. It caught our attention and left us baffled. In the end, the brightness puzzle remains unsolved, a chapter in a story of mysteries without resolution. Some say it was ice, some say it was geometry, some whisper it was technology. But none can deny the truth. 3i Atlas pulsed in ways no ordinary rock should. It flashed like a message, faded like a ghost, and slipped into the dark, leaving only questions. And so we are left staring into the night, haunted not only by the object itself, but by its light, the flickers that should not have been, the brightness that made no sense, the puzzle that lingers long after the visitor is gone. Perhaps the truth lies in the data we lost, or in the instruments we lacked. Or perhaps the truth was never meant for us, hidden in a language of light we cannot yet read. Whatever the answer, the brightness puzzle is a reminder that the universe is not silent. Sometimes it speaks not in sound, but in flashes. And sometimes those flashes are not just illumination. They are mystery itself, shining and vanishing like a heartbeat from the stars. The silent messenger. When 3i Atlas streaked into our solar system, one theme quickly emerged from the conversations of astronomers, philosophers, and dreamers alike: silence. Unlike comets that roar with tails of gas, unlike asteroids that blaze with heat signatures, unlike stars that sing with radio noise, this visitor moved quietly, leaving behind no trail, no heat, no signals. And yet, in that very silence, it seemed to speak. Many began to call it the silent messenger, a presence that delivered meaning without a single word. The phrase caught on because 3i Atlas behaved less like a random fragment and more like a courier. It arrived suddenly, caught our attention, defied explanation, and then slipped away again. Its message was not carved into stone, not carried by sound, but written in absence. In science, absence is often overlooked, But with Three Eye Atlas, absence became the message itself. The silence started with its physical body. No outgassing, no cometary tail, no whisper of dust. Comets usually shout their existence, flaring as they near the sun. Asteroids betray themselves with reflected heat. But Three Eye Atlas refused both roles. It carried no signature, as if it were deliberately hiding what it was made of. To observers, this silence was maddening. It denied them the data they needed to classify it, and yet, by withholding, it spoke. It said, "I will not be easily known." Then came the silence of radio. When Oumuamua had passed 3 years earlier, radio telescopes were tuned to listen, hoping for unnatural signals. None were found. With Three Eye Atlas, they listened again. Breakthrough Listen, the ambitious SETI project, reportedly tracked it carefully. Again, no signals. No pings, no pulses, no encoded transmissions. To some, this proved it was natural. To others, the silence was more eloquent than noise. A true messenger need not broadcast. Its mere presence can be communication enough. A silent messenger is harder to dismiss than one that shouts. The silence continued in its path. Three Eye Atlas threaded the solar system without colliding, without being captured, without lingering. It avoided every gravitational trap, moving as though it knew its course. Its trajectory was not noisy chaos, but a clean line, a passage designed to be temporary. If it had struck a planet, its message would have been destruction. If it had stayed, its message would have been contact. But by passing through, touching nothing, it delivered the strangest message of all. I was here, and now I am gone. Why would silence be the message? History offers clues. In many cultures, silence is sacred. Native American traditions speak of silent signs in the sky as teachings from the Great Spirit. In Buddhism, silence is enlightenment itself, a communication beyond words. In Christian mysticism, silence is the voice of God, louder than any sermon. The Egyptians associated silence with Thoth, the god of wisdom, whose teachings were hidden in symbols and riddles. Across the world, silence is not emptiness, it is fullness, presence distilled into stillness. Three Eye Atlas, in its refusal to speak, joined this tradition of silent teachers. Some theorists argue that silence is the most efficient form of communication on a cosmic scale. Imagine civilizations millions of years apart in age, separated by languages and contexts we cannot imagine. Any attempt at words or codes could fail, but silence, timed silence, deliberate silence can carry a message no one can mistake. We are here, we are watching, we passed this way. A silent messenger is universal. It forces the observer to project meaning, to confront their own assumptions. That, in itself, is the communication. Others take the idea further. What if Three Eye Atlas was not trying to speak to us, but to someone else? If interstellar highways exist, as many believe, then it may not have been passing randomly, but along routes used by many. In that case, silence was camouflage. A messenger traveling between worlds must move quietly to avoid detection by those not meant to hear. Its silence, then, was not for us, but for them. We may have simply eavesdropped on a message never intended for our eyes. Yet silence does not always mean emptiness. Astronomers studying its light curves noticed flickers, pulses, and irregularities. Were these artifacts of shape and spin, or were they signals hidden in the noise? If so, then silence was an illusion. The messenger may have spoken, but in a language we did not understand. A flash of light could be a 0, a fade could be a 1. The object's rotation could have been a code, a beacon flashing across the dark. We looked, we recorded, and we left puzzled. If that was the message, it was successful, not because we decoded it, but because we recognized there was something to decode. The silent messenger resonates with a darker interpretation as well. Perhaps its silence was a warning. In human warfare, silence often precedes attack. A quiet battlefield, birds gone still, an enemy unseen, that silence is not comfort, but dread. What if Three Eye Atlas was a scout, silent because it was gathering information, observing without revealing itself? If so, then its silence was not a message of peace, but of surveillance. It said, "You are noticed. You are measured. We do not need to speak." And yet, even this interpretation underscores the same truth. Silence is never neutral. It always carries meaning, whether as peace, as warning, or as enigma. The silent messenger forced humanity to grapple with its own fears and hopes. Some saw it as a benign teacher, reminding us of humility. Others saw it as a spy, evidence of watchers in the dark. Still others dismissed it as coincidence, a natural rock whose silence was only our ignorance. But in every case, the silence spoke. The scientific community continues to wrestle with the implications. Without outgassing, without dust, without signals, classification of 3I Atlas remains tentative. Was it a fragment of a planet? A shard of metal-rich debris? A probe long dead, drifting silently across the galaxy? Each hypothesis reflects a different interpretation of its silence, but no one can deny that silence defined it more than any other trait. The silent messenger also raises questions about ourselves. Why did we notice it at all? Why did its silence haunt us? Perhaps because silence is what we fear most. In a universe we hope is alive with intelligence, silence feels like abandonment. To imagine that someone might have sent a messenger and that it chose not to speak cuts deeper than outright solitude. It suggests that communication is possible but withheld, that there is a message but we are not ready to hear it. In the end, the mystery remains. 3I Atlas entered, crossed, and left, all in silence. No voice, no trail, no answers. Only the haunting sense that something had brushed against our world, reminding us of how small we are. Perhaps it was natural that a shard of stone indifferent to our questions. Perhaps it was artificial, a probe carrying meaning we could not understand. But in either case, its silence was the point. For silence is not absence, it is presence in another form. It is a messenger that forces us to fill in the gaps, to confront our own limits, to ask questions we might not otherwise ask. And in that sense, 3I Atlas accomplished what no signal could have done. It spoke without sound. It taught without teaching. It delivered a message we still argue about today. The silent messenger has vanished now, slipping into the endless dark, but its silence lingers, louder than words, a question hanging in the night sky. Was its silence chance or design? And what if the real message is not in its silence at all, but in our reaction to it? That, perhaps, is the riddle it left behind, that sometimes the loudest voice in the cosmos is not the one that speaks, but the one that does not. The life raft theory. When 3I Atlas passed through our solar system, much of the debate revolved around its speed, its brightness, its silence, and its bizarre trajectory. But one of the strangest and most unsettling speculations came from a handful of scientists and futurists who asked a different question. What if this object was not just rock or machine? What if it carried life? Thus emerged what came to be called the life raft theory. The idea that 3I Atlas was not a barren fragment, but a vessel, intentionally or accidentally ferrying the seeds of biology across the stars. The life raft theory draws on an ancient concept in science, panspermia. This hypothesis suggests that life might not have begun on Earth, but could have been delivered here by comets, meteorites, or interstellar dust. Microbes can be surprisingly resilient, capable of surviving in the vacuum of space, in frozen rock, and even under radiation that would obliterate larger organisms. Over billions of years, fragments of worlds shattered by impacts might have carried microorganisms across cosmic distances, seeding life wherever conditions allowed. If true, then Earth itself is not isolated, but part of a larger web of life spread throughout the galaxy. 3I Atlas, then, becomes a candidate for such a role. Its dustless, hardened surface could act like a protective shell, shielding whatever lies inside from cosmic radiation. Its clean trajectory through the solar system, avoiding planets and leaving no debris, would make it difficult to detect, perfect for a vessel meant to travel undisturbed. And its interstellar origin means that if it did carry life, it was delivering biology from another star system, perhaps entirely unrelated to our own. The implications of this are staggering. If microbes clung to 3I Atlas, then when it passed through our solar system, it may have shed particles invisible to our instruments. Perhaps a microscopic fragment broke free, carried by solar winds to some distant world. Perhaps it left nothing this time, but objects like it have been delivering life across the galaxy for eons. In this view, 3I Atlas was not just a visitor, it was a life raft. Some proponents of the theory note the timing of its arrival. Both Oumuamua and 3I Atlas passed close to Earth within just a few years of each other, after billions of years in which no such visitors had ever been detected. Was this coincidence, or part of a greater pattern? Could the galaxy be alive with rafts, drifting from system to system, scattering seeds of life like spores on the wind? If so, then we are not alone. Not because intelligent civilizations are watching us, but because the galaxy itself is a garden, sowing life wherever it can. Yet there is another, darker interpretation. What if the life raft theory is correct, but the life it carries is not benign? Microbes evolved in alien conditions could be lethal to Earth's biosphere. A single invasive species, invisible and unrecognized, could alter ecosystems beyond repair. To some, 3i Atlas was not just a possible seed, it was a possible plague. The idea recalls myths from ancient cultures about sky plagues, diseases brought by comets and wanderers from the heavens. The Black Death of the 14th century, for instance, was linked by some chroniclers to strange lights in the sky. To modern ears, these stories sound superstitious, but in the shadow of 3 Atlas, they sound eerily prophetic. Scientists counter that the odds of viable microbes surviving interstellar journeys are slim. Space is cold, radiation-filled, and hostile. Millions of years in the void would sterilize most organisms, yet research has shown surprising resilience. Tardigrades, tiny water bears, can survive vacuum and radiation for years. Spores of certain bacteria have survived exposure to space aboard the International Space Station. If earthly life can endure so much, might alien microbes endure even more? The life raft theory also intersects with ancient myths of life from the stars. The Dogon people of Mali tell of their ancestors receiving life from the star Sirius. Hindu texts speak of beings descending from the heavens to plant the seeds of existence. Even the Greeks imagined the gods scattering life across the world from Olympus. Perhaps these myths are symbolic echoes of a cosmic truth, that life itself is nomadic, carried between worlds on rafts of stone and ice. Philosophically, the life raft theory forces humanity to reconsider its own story. We often imagine ourselves as unique, born of Earth alone. But if panspermia is real, then our ancestry stretches far beyond this planet. We are children not of Earth, but of the stars. And if 3 Atlas was a life raft, then it may be a distant cousin, carrying the same spark that gave rise to us. Or carrying a different spark entirely, one that might have thrived had it landed here long ago. There is also the possibility of design. What if 3i Atlas was not just accidentally carrying microbes, but deliberately seeded with them? An advanced civilization might spread life intentionally, launching probes or fragments across the galaxy to terraform barren worlds. This directed panspermia was proposed by Nobel Prize-winning scientist Francis Crick, co-discoverer of DNA. If 3i Atlas were such a craft, then it was not just a fragment of biology, it was a mission, a seed sent to grow life far from its origin. This raises haunting questions. Was it still active, releasing life as it passed? Or was it long dead, a forgotten seed that never found its soil? How many other rafts like it have passed Earth unnoticed, shedding or failing to shed their cargo? And if life here came from such a raft, are we not then the living message of someone else's experiment? Skeptics dismiss the life raft theory as science fiction. They argue that the silence of 3i Atlas proves nothing beyond our own ignorance. And yet the absence of dust, the strange acceleration, the anomalies in brightness all combine to make it unlike anything else we have seen. It was either the most unusual rock in history or something more. If even 1% of its mystery points toward life, the implications are worth considering. The life raft theory also reframes our understanding of interstellar visitors. Instead of treating them as curiosities, we might treat them as archives, libraries of alien biology drifting between the stars. To study one up close could answer the greatest question of all, are we alone? For if microbes from another star were found clinging to 3i Atlas, then the answer would be no. Life is everywhere, scattered not by accident, but by a cosmic process as old as the galaxy itself. In the end, 3i Atlas slipped away, taking its secrets with it. We will never know if it carried life. But the life raft theory lingers, an idea as haunting as it is inspiring. Perhaps our world itself was seeded by such a visitor. Perhaps life here is the echo of another life, far away, long gone. And perhaps, as 3i Atlas passed silently by, it was not only reminding us of our fragility, but also of our kinship with the stars, with the void, and with every wandering fragment that carries the spark of existence. The life raft theory leaves us with a question both humbling and terrifying. What if we are not the only children of the stars, but merely one branch of a vast family tree, whose seeds drift endlessly across the universe on silent, dustless rafts? And if so, then 3 Atlas was not a stranger at all, but kin, a messenger carrying life's eternal story from one world to another. The star it may have left. Every object has an origin. A comet comes from the icy reservoirs of the Oort cloud. An asteroid can be traced back to the rubble of the asteroid belt. Even the dust in our atmosphere carries the fingerprint of stars that died billions of years ago. Yet, when it comes to 3 Atlas, the question of origin has proven nearly impossible to answer. Astronomers, eager to chart its course backward through the galaxy, found that the path it traveled did not point cleanly to any known star system. It was as though 3I Atlas had stepped onto the stage of our solar system from a void without a curtain. Still, some tried to answer the question, what star did it leave behind? The task began with trajectory modeling. By plotting the object's speed and angle of approach, scientists could, in theory, reverse its course to identify its parent system. For many comets, this method works beautifully. Their orbits can be traced back to specific reservoirs, their journeys mapped with elegant precision. But 3I Atlas refused this simplicity. Its trajectory, instead of pointing neatly toward a nearby system, scattered across the sky in a spread of probabilities. Like dice rolling across a table, each calculation suggested a different outcome. Some pointed to stars just a few dozen light-years away. Others suggested systems hundreds of light-years distant. No single answer held. One candidate was Vega, the bright star in the constellation Lyra, just 25 light-years from Earth. Some models showed 3I Atlas's path intersecting with Vega's neighborhood around 600,000 years ago. Yet this explanation faltered under scrutiny. Vega's proper motion, its drift through the galaxy, made the timing uncertain. When astronomers adjusted for the star's movement, the connection fell apart. Vega was a possibility, but a weak one. Another candidate was the Carina-Columba Association, a group of young stars about 60 million years old and roughly 300 light-years away. In this theory, 3I Atlas might have been ejected during the turbulent formation of one of these young systems. If true, it was not just a fragment, but a relic of stellar birth, cast out into the void during the chaos of planetary formation. This explanation had appeal. It gave 3I Atlas the aura of a time capsule, carrying within it the story of a star's early days. Yet again, the probabilities were thin, the uncertainties vast. Others pointed to more distant candidates, stars in the Perseus arm of the galaxy, drifting clusters far beyond our immediate neighborhood. If 3I Atlas came from there, it had traveled for millions of years, perhaps even tens of millions, before arriving here. That possibility gave it an almost mythical quality. Imagine a fragment launched when dinosaurs still walked Earth, wandering for ages before brushing against our solar system like a ghost from another era. The problem was not only uncertainty, but also speed. 3I Atlas was moving too fast for easy tracing. Objects bound to stars carry predictable velocities, shaped by the gravitational pull of their origins. 3I Atlas, however, moved like a runaway, too quick, too free, as though hurled deliberately or accelerated by forces unknown. This made tracing it back a nearly impossible task. It could have left its star billions of years ago, its origin blurred by eons of drift. By the time it reached us, it was unmoored not only from its parent star, but from certainty itself. This uncertainty gave rise to speculation. What if 3 Atlas did not leave a star at all? What if it came from the dark gulfs between, from interstellar space itself? Could it be the fragment of a rogue planet torn apart by collision? Could it have been born not in the nursery of a star, but in the cold emptiness where galaxies trade their debris? If so, then its origin was not a star at all, but the void. It would be a child of nothing, a wanderer without a home. And yet humans crave origin stories. To imagine that 3 Atlas came from nowhere is unsatisfying. Thus, the search for its star continues, not because the data demand it, but because our minds demand it. We need to know what kind of cradle cast out this visitor. A gentle, sun-like star, a violent red dwarf prone to flares, a cluster where collisions were common. Each possibility paints a different story. Consider the implications if it came from a system like ours, with stable planets and calm orbits. In that case, 3I Atlas might be a fragment of a shattered world, a planet torn apart by impact or gravitational chaos. Studying it up close might have revealed what alien geology looks like, a piece of a world we will never otherwise see. If, on the other hand, it came from a red dwarf system, perhaps it was hardened by radiation, scarred by flares, forged in conditions hostile to life. In that case, its very strangeness would reflect the harshness of its birthplace. Then there are the even stranger speculations. What if 3 Atlas was not ejected naturally, but launched? An advanced civilization might hurl objects into interstellar space for exploration or communication. Its path, too clean and efficient, might not be random, but engineered. In that case, the star it left was not just a birthplace, it was a sender. And we, by witnessing its passage, became unintended recipients. The mystery then is not only which star it left, but who lived there and why they sent it. The cultural echoes are uncanny. Myths from many civilizations describe stars as messengers. The Polynesians spoke of traveling stars that guided navigation across the seas. The Egyptians believed the souls of the dead became stars, traveling into the night sky. In Greek myth, shooting stars were seen as omens, sparks cast from divine hammers. All of these stories link stars with origin and departure, with journeys that begin somewhere else. 3i Atlas fits this archetype perfectly. A traveler whose star remains hidden, a story half told. The star it may have left, then, is less about astronomy than about longing. We want to know where it came from, not only to classify it, but to connect with it. Its origin is its story. Without it, we are left with a character who enters a play mid-scene, speaks no lines, and exits before we know their name. That absence haunts us. It reminds us that the universe is not obliged to explain itself, and that sometimes we see only fragments of larger stories. And perhaps that is the truest message of all. The star it may have left is both everywhere and nowhere. It could be Vega or Carina Columba or some forgotten world long extinguished. It could be a star yet unnamed or no star at all. The object itself will never tell us. It has left its star behind, and in doing so, it has left us behind too, searching the sky for origins that may never be found. Yet the search continues. Astronomers refine their models, run new simulations, test new theories. They may never succeed, but the effort itself speaks to our nature. We cannot let go of the question, where did it come from? The mystery of 3i Atlas is not only about its strangeness in the present, but about its silence regarding the past. Its journey is a reminder that origins matter, that to know something, we must know where it began. And so, the star it may have left remains one of the most tantalizing riddles of 3 Atlas. It is a riddle without an answer, a door without a key. Perhaps someday another object will arrive whose path can be traced more clearly, revealing its parent star and ending the debate. Until then, 3 Atlas drifts into legend, a silent traveler, forever raising the question of the star it may have left, and the stories it carried with it into the dark. The Interstellar Beacon. When 3i Atlas passed through the solar system, most astronomers classified it as a natural fragment, a shard of rock or ice cast loose from some distant star. Yet, from the beginning, its behavior defied ordinary explanation. Its acceleration, its silence, its dustless surface, its strange flickers of brightness, all of these anomalies piled up until one theory, whispered first on the fringes and later creeping into mainstream debate, began to take shape. What if 3i Atlas was not just a wanderer? What if it was a beacon, an interstellar signal left adrift to announce the presence of intelligence across the galaxy? The idea of an interstellar beacon is not new. For decades, SETI researchers have speculated that advanced civilizations might leave behind markers designed not to communicate complex information, but to serve as cosmic lighthouses. A lighthouse does not tell a sailor where to go or what to do. It simply announces, "You are not alone, there is land here." In the same way, a beacon from another world would not need to carry a message in words. Its very existence would be the message. 3i Atlas seemed to fit this role uncomfortably well. First, there was the matter of timing. After billions of years in which humanity had never detected an interstellar visitor, 2 appeared within 3 years of each other, Oumuamua in 2017, then 3i Atlas in 2020. Both displayed anomalies that resisted natural explanation. Both were noticed just as humanity's telescopes became capable of detecting them. To some, this timing looked less like chance and more like choreography, as if the beacon had been placed where we would be certain to notice it. Then there was its silence. Radio telescopes scanned 3i Atlas for transmissions and found nothing. But a beacon would not need to speak in radio. Its form itself could be the signal. Its unusual shape, its strange reflective properties, its trajectory too clean to be chance. All of these could be intentional, designed not to communicate data, but to spark recognition. The message would be simple. Something unnatural is out here. Something is watching. Brightness variations strengthen this suspicion. The light curve of 3I Atlas pulsed irregularly, flashing brighter and dimmer in ways that seemed almost rhythmic. To cautious astronomers, these were just reflections of its tumbling body. To others, they looked like modulation, the crude beginnings of a code. A lighthouse does not speak words, it flashes light. Could 3I Atlas have been designed to flash in the same way? Not for us necessarily, but for anyone. Skeptics argued that such speculation went too far. To call an object a beacon is to leap from data to desire, from fact to faith. And yet the anomalies remained. The lack of dust, the missing heat, the unexplained acceleration, each of these could be rationalized in isolation, but together they formed a portrait of strangeness too sharp to ignore. If 3 Atlas was not a beacon, it was at least something that resembled one. History provides strange echoes of this idea. Ancient peoples often spoke of celestial fires that announced great change. The Chinese chroniclers wrote of guest stars appearing suddenly in the heavens as omens. The Norse described Bifrost, the rainbow bridge that connected the worlds, glowing in the night sky. In the Hebrew Bible, a star is said to have guided the Magi to Bethlehem. Again and again, cultures describe lights in the heavens not as accidents, but as signs. To imagine 3I Atlas as a beacon is to see it in this same tradition, a star not born of fusion, but of intent. Philosophically, the beacon theory reframes the question of extraterrestrial life. We often imagine alien contact as a conversation, signals exchanged, messages decoded. But what if the first step is not conversation, but recognition? A beacon is not dialogue, it is invitation. It says, look closer, we exist. The complexity comes later. 3 Atlas, in this light, was not a failed conversation, but the opening gesture of one. And perhaps that is why it remains silent. Words are fragile across cosmic distances. Codes may be misunderstood, but silence combined with strangeness is harder to dismiss. By refusing to behave like a comet, refusing to emit dust, refusing to glow with heat, 3I Atlas forced astronomers to pay attention. Its silence was not emptiness, it was deliberate ambiguity, the essence of a beacon. But if it was a beacon, who was it for? Was it placed to catch the eyes of young civilizations like ours, just now building telescopes? Was it meant for more advanced watchers, cruising along interstellar highways we barely understand? Or was it part of a chain, one of many beacons drifting through the galaxy, each carrying the same silent message? In that case, 3I Atlas was not unique. It was one light among thousands scattered across the stars. The theory raises unsettling questions. A lighthouse warns of danger as much as it announces safety. Could 3I Atlas have been a warning left behind by one civilization for another? Its silence might not mean welcome. It might mean beware. A beacon in the dark could be a marker of territory, a line drawn across space. Or worse, it could be bait placed to lure the curious. The same ambiguity that makes it fascinating also makes it frightening. Scientists wrestle with this ambiguity. The majority dismiss the beacon theory as speculation, preferring natural explanations no matter how strained. But a smaller group argues that ignoring the possibility is unwise. If we treat every anomaly as coincidence, we may miss the very message we claim to seek. They point to the SETI paradox. We say we are looking for signals, but when something strange appears, we dismiss it as noise. What if 3I Atlas was the signal and we turned away? The interstellar beacon theory also forces us to reflect on ourselves. If we were to send a message across the galaxy, how would we do it? We might launch probes, knowing that signals degrade and civilizations may not share our wavelengths. We might design them not to speak but to be seen, their forms themselves the language. We might send objects that defy natural categories, forcing others to ask, is this a coincidence or is it a message? In imagining 3I Atlas as a beacon, we are imagining ourselves, and yet the object is gone. Whatever message it carried, if message it had, was fleeting. It left us only with questions, the way a lighthouse glimpse on the horizon leaves sailors wondering about the shore beyond. Was it natural? Was it artificial? Was it beacon or rock? The answers drift beyond our reach, but the question itself lingers, shaping how we look at the next visitor. If another object arrives with the same anomalies, the theory will no longer be easy to dismiss. Two coincidences begin to form a pattern. Three begin to form a map. In the end, 3I Atlas left us with the haunting possibility that the universe is not silent. It is speaking, but not in the ways we expect. The interstellar beacon theory does not claim certainty. It claims suspicion. A suspicion that the strangeness of this visitor was the point, that its anomalies were not flaws, but features. A beacon does not need to explain itself. It only needs to shine to say, look, notice, remember. And we have noticed. We remember. 3I Atlas has vanished into the darkness, but the thought it planted remains, that perhaps the galaxy is threaded with lighthouses, some natural, some artificial, all waiting for eyes to see them. The question is not whether we are alone, but whether we are paying attention. The interstellar beacon is gone, its light extinguished or carried far beyond our reach, but in its wake it left a glow, not in the sky, but in our minds. The glow of possibility, the glow of suspicion, the glow of a question that will not die. What if the first message from the stars has already passed, and it was silent, brief, and shaped like a shard of stone? The impossible longevity. Every rock, every shard of ice, every drifting fragment in the cosmos bears scars of time. Solar radiation erodes surfaces, cosmic rays shatter atomic bonds, micrometeoroids pummel and grind. Over millions of years, even the hardest objects are scarred beyond recognition. Yet, 3I Atlas, traveling through interstellar space for perhaps millions or even billions of years, arrived in our solar system appearing strangely intact. It showed no obvious erosion, no disintegration, no trail of debris betraying its age. For some, this was the most confounding puzzle of all. Its impossible longevity. Natural objects are not built to last forever. Comets from the Oort cloud, which spend only a fraction of their lives in interstellar darkness, already show wear when they return to the sun. Asteroids bear the marks of endless collisions, their surfaces cratered and fractured. Even dust grains, tiny though they are slowly pulverized by radiation and interstellar shockwaves. Yet 3I Atlas seemed different. It crossed the void like a survivor, as though it had resisted the grinding effects of cosmic time in ways we could not explain. This raised the first great question. How old was it, really? To arrive at our solar system from even the nearest stars, 3I Atlas would have traveled for tens of thousands of years. If it came from more distant regions, clusters hundreds of light years away, it could have been adrift for millions. And if it were truly ancient, perhaps ejected during the early history of the galaxy, then it may have been traveling for billions of years, predating humanity itself. By all rights, such a body should have been ground into dust long before it reached us. Yet here it was, intact enough to puzzle us with its shape, its brightness, its silence. Scientists proposed that perhaps it was made of exceptionally resilient material. Some speculated that 3 Atlas could be metallic, forged in the violent heart of a star, its surface hardened against cosmic rays. Others suggested exotic ices, frozen so solid in interstellar cold that they resisted erosion. Yet even these explanations felt incomplete. Metals corrode under bombardment, ices sublimate, nothing lasts forever in the void. To survive such a journey, 3I Atlas would need more than toughness, it would need design. This possibility led some to speculate about artificiality. What if 3I Atlas was built, not born? A probe or vessel crafted to endure millennia of travel would need exactly the kind of longevity this object displayed. Its surface might have been engineered to resist radiation, its structure designed to withstand collisions. Perhaps it was not simply a rock, but a time capsule, meant to carry its form intact across eons. If so, then its impossible longevity was not coincidence, but purpose. It was proof that someone, somewhere, had solved the problem of time. The implications of this are staggering. For us, space exploration is constrained by duration. Probes like Voyager 1 and 2, launched in the 1970s, are already nearing the limits of their lifespans. Their instruments degrade, their power fades, their bodies corrode. Even our most advanced designs cannot hope to survive millions of years intact. Yet 3I Atlas appeared to have done exactly that. If it was artificial, then it embodied a mastery of longevity beyond anything we can imagine. If it was natural, then it revealed that the universe can forge bodies far more enduring than our models predict. The impossible longevity also carried philosophical weight. It suggested that time itself may not be the barrier we think it is. If a fragment can travel for millions of years and remain intact, then perhaps the galaxy is filled with such survivors. Relics of worlds long gone, civilizations long dead, or processes we barely understand. 3I Atlas may not have been unique. It may have been one of countless wanderers, each carrying within them the record of impossible ages. Yet this endurance raises unsettling questions. Why here? Why now? If 3I Atlas was truly ancient, why did it cross our path in this brief window of human history, when we had just developed the tools to notice it? The coincidence seems almost cruel. For billions of years, it drifted unseen. Then, within a few short decades of our first serious sky surveys, it appeared, only to vanish before we could study it properly. The longevity that allowed it to reach us also ensured that we were too unprepared to decode it. Mythology provides strange echoes of such themes. Many cultures speak of eternal stones, artifacts that outlast civilizations. The Norse told of Ymir's bones, the remnants of the first being, lasting until the end of time. The Egyptians wrote of Ben stones, primordial relics from creation itself. In Hindu myth, the Shiva lingam is described as a cosmic stone without beginning or end. These myths imagine permanence in a universe of change. In 3 Atlas, we may have glimpsed a real-world echo, an object whose endurance mocked the fragility of all things human. From a scientific perspective, the longevity puzzle forces us to rethink the harshness of interstellar space. Perhaps it is not always as destructive as we assume. The vast emptiness between stars may be gentler than expected, allowing some objects to drift relatively untouched. Collisions are rare in the void. Radiation is diffuse. A fragment launched at just the right angle, at just the right speed, might wander for eons without significant damage. If true, then the galaxy may be littered with ancient survivors waiting to be discovered. But even if this natural explanation is correct, the improbability remains. For one to survive, millions must perish. For us to witness 3 Atlas at all suggests either extraordinary luck or something more deliberate. Some astronomers whispered that perhaps it was not a survivor by chance, but a selection. Out of countless fragments, only those designed or destined for longevity endure. In that sense, 3 Atlas was not just an outlier, it was the chosen one. The impossible longevity also reframes our understanding of cosmic history. If fragments like this can endure for millions of years, then they become messengers of the past. They carry within them the record of their birth stars, their shattered worlds, their violent ejections. To study one up close would be to read the diary of a star system long gone. But instead of answers, we were given only the question, how did it last this long? Some philosophers take the theory further. What if longevity itself was the message? A silent traveler, intact after millions of years, demonstrates that survival is possible. It shows us endurance beyond our comprehension. It whispers that time, the great destroyer, can be resisted. If 3 Atlas was a probe, its greatest message may not have been technology or language, but persistence. To endure is to speak. To survive is to communicate. Its silence was not absence, it was longevity turned into a voice. And yet the mystery remains. We cannot prove whether 3I Atlas was natural or artificial, whether its impossible longevity was the result of chance or design. What we know is that it lasted long enough to cross into our skies, long enough to challenge our assumptions, long enough to haunt us with questions. That endurance, impossible as it seems, is the essence of its mystery. As it drifts farther into darkness, beyond the reach of our instruments, we are left only with echoes. 3I Atlas may still be out there, tumbling intact, carrying its secret resilience into the infinite. It may survive for millions more years, passing other stars, other civilizations, leaving them as puzzled as we are. Its longevity is not only impossible, it is eternal, at least in the scale of human history. And perhaps that is the true message. Not speed, not brightness, not silence, but endurance. 3I Atlas is a reminder that some things outlast understanding, that the universe is not only vast in space, but endless in time. We are brief. It is not. And in its impossible longevity, it tells us a truth we can barely grasp, that what survives longest may be the greatest mystery of all. The double arrival. For most of human history, the idea of an interstellar object passing through our solar system was purely theoretical. Astronomers speculated that fragments of distant worlds might occasionally drift our way, but no one expected to actually see one. Then, in 2017, Oumuamua appeared. It was unlike anything previously observed. Elongated, accelerating without explanation, tumbling with brightness variations that defied simple models. Scientists debated fiercely whether it was a comet, an asteroid, or something stranger. Many concluded we might never know. And then, just 3 years later in 2020, 3I Atlas arrived, another interstellar visitor, equally strange, equally defiant of natural categories. One such sighting in the span of human observation might be dismissed as coincidence. 2. Arriving so close together in time is something else. This became known among researchers, journalists, and enthusiasts as the double arrival. To some, it was proof that interstellar objects are far more common than once thought, merely overlooked until our instruments improved. To others, it was too neat, too timed, too deliberate. Why should two anomalies arrive within years of each other after billions of years of silence? Was this random chance, or the first act of a larger story? The statistical argument is compelling. Before 2017, no confirmed interstellar objects had ever been detected. Scientists assumed that such visitors must be exceedingly rare. But after Oumuamua and 3I Atlas, estimates changed dramatically. Perhaps billions of interstellar fragments wander through the galaxy, and Earth simply hadn't noticed. Our telescopes designed to track asteroids near Earth had only just become sensitive enough to catch such fast-moving bodies. In that case, the double arrival was not design but discovery, a window opening onto a reality that had always been there. Yet the anomalies complicate this explanation. Neither object behaved like a simple shard of rock. Both accelerated in ways gravity alone could not explain. Both defied classification as either comet or asteroid. Both left scientists puzzled, theories clashing without resolution. If they had been ordinary, the coincidence might be easier to accept. But for two extraordinary objects to arrive so close together, that made the double arrival suspicious. The suspicion deepened when patterns emerged between them. Oumuamua showed no cometary tail, yet still accelerated mysteriously. 3I Atlas, too, displayed comet-like behavior without the expected outgassing or dust. Both were silent in radio scans. Both flickered strangely in brightness, as though reflecting light from surfaces not entirely natural. Both slipped through our solar system quickly, vanishing before deeper study could be arranged. It was as though they followed the same script: arrive, puzzle, depart, leaving only questions behind. This script-like similarity raised the possibility of coordination. Could they have been sent deliberately, one after another? If so, what was the purpose? Some suggested reconnaissance. The first a scout, the second a confirmation. Others imagined them as signals, paired messages to draw attention. A single anomaly might be ignored, but two in succession would force recognition. It is one thing to doubt coincidence once, it is another to doubt it twice. Ancient myths echo this pattern of doubling. The Babylonians spoke of twin stars that appeared together as omens of change. The Greeks told of Castor and Pollux, the divine twins who guided sailors, never one without the other. In Chinese lore, the appearance of two guest stars was a harbinger of dynastic upheaval. Again and again, cultures framed doubles as deliberate, meaningful, never accidental. When two anomalies arrive, humanity instinctively seeks significance. Scientists, though cautious, admitted the double arrival posed uncomfortable questions. If such objects are common, where are the others? Why had we not seen them earlier? And why, after billions of years, did two appear just after humanity gained the tools to notice? This timing was uncanny, almost mocking. It suggested either that we had been blind until now, or that something had changed in the galaxy itself. One theory is that both were fragments from a larger parent body, shattered long ago and traveling together across space. If true, the double arrival was not coincidence, but kinship. Siblings separated by distance, now arriving in sequence. This would explain their similarities in behavior, their shared refusal to fit categories. But it also raised a chilling possibility. If two siblings had come, others might follow. Perhaps a swarm of such fragments is on its way, some smaller and unnoticed, others larger and more dangerous. The double arrival might not be the end of the story, but the beginning. Another theory pushes beyond nature. If they were probes, then the double arrival could represent phases of a mission. Oumuamua, the loud scout, created debate and fascination. 3 Atlas, quieter but equally strange, followed. 2 signals reinforcing each other. Like 2 knocks on a door, their purpose may have been to announce, not explain. Together, they whisper a message humanity cannot ignore. You are not alone. We pass this way. This idea unsettles because of its ambiguity. A double signal could be a greeting or a warning. Sailors who once saw 2 lighthouses on a shore knew they were approaching something significant, but not whether it was safe or perilous. The double arrival may be the same, a sign that someone or something has marked our solar system as worthy of notice. But notice can mean many things: curiosity, survey, claim. Culturally, the double arrival has already shaped imagination. Films, novels, and art echo with the idea of paired visitors, cosmic twins sent from beyond. It has revived interest in panspermia, in alien probes, in ancient myths of skyborne messengers. It has blurred the line between science and story because the story itself feels uncanny. 2 visitors, both strange, both fleeting, both impossible to dismiss. This is not just data, it is narrative, a sequence humanity cannot help but interpret as deliberate. Philosophically, the double arrival forces us to reconsider our assumptions about rarity. We imagine ourselves alone because evidence of others has not appeared. But what if evidence arrives not as radio signals, but as silent objects? What if the galaxy is alive with visitors, each slipping past too quickly for us to see? Oumuamua and 3I Atlas may not be anomalies at all. They may be the first glimpses of a cosmic traffic we have been blind to until now. And yet the mystery persists. 2 arrivals are enough to disturb, but not enough to explain. Were they natural or artificial? Coincidence or coordination? Warning or invitation? The double arrival leaves us balanced on the knife edge of uncertainty, knowing too much to dismiss, but too little to conclude. Perhaps that is the true power of the double arrival. It is not in the answers it gives, but in the questions it demands. It forces us to admit that our models are incomplete, our assumptions fragile, our knowledge thin. It reminds us that the universe does not need to obey our sense of probability, and it whispers that perhaps, in the silence of the stars, patterns exist that we have only just begun to glimpse. Oumuamua has gone. 3 Atlas has gone. Their paths diverge now into the darkness, but the echo of their double passage remains, a mystery too sharp to forget. Whether coincidence, kinship, or communication, the double arrival marks a turning point in our relationship with the cosmos. For the first time, humanity has not just glimpsed one stranger in the night sky, but 2, and in that doubling, everything changes. The double arrival may one day be remembered not as anomaly, but as first contact, not with words, not with signals, but with presence itself. 2 visitors, silent and brief, yet together delivering a message humanity cannot ignore. We are part of a larger story, and the story has only just begun. The next visitor. The story of 3I Atlas and of its predecessor Oumuamua leaves us with a haunting anticipation. If 2 interstellar objects have already passed so close to Earth in so short a span of time, then surely there must be others. This anticipation has crystallized into what many call the next visitor, the inevitable arrival of another wanderer from the stars. For some, it is a purely scientific expectation. For others, it carries the weight of prophecy, a sense that the universe is preparing us for revelations we are not yet ready to face. Astronomers know one thing with certainty: 3 Atlas and Oumuamua were not isolated events. The galaxy is teeming with debris, shards of shattered planets, comets ejected from unstable systems, and fragments of collisions older than humanity itself. If 2 have crossed our skies in just a few years, then countless others must be drifting invisibly in the void. The difference now is that we have the technology to see them. Telescopes like Pan-STARRS in Hawaii, Vera C. Rubin Observatory in Chile, and future sky surveys will catch more of these travelers as they streak across our field of vision. The question is no longer if the next visitor will come, but when. And yet the scientific certainty of their abundance does not erase the deeper mystery. Will the next visitor behave like a comet, glowing with a tail and scattering dust? Or will it, like its predecessors, defy every category we know? If Oumuamua and 3I Atlas were anomalies, then perhaps the next visitor will be ordinary, a reminder that most interstellar debris is unremarkable. But if the next visitor is strange again, if it accelerates without cause, if it flickers in unnatural rhythms, If it refuses to behave like rock or ice, then the pattern will be undeniable. 2 might be coincidence. 3 begins to feel like intention. The anticipation of the next visitor has already stirred philosophical debates. What if these objects are not random shards, but scouts? What if their sequence, Oumuamua, then 3i Atlas, represents the beginning of a long procession? Each one, a silent messenger testing our awareness, measuring our curiosity. In that case, the next visitor may not be an accident of observation, but the next chapter in a design. The question then becomes, what story is being told? In myth and legend, the theme of the next arrival recurs with eerie familiarity. The Hopi spoke of a sequence of sky signs that would herald great change, each one stranger than the last. Norse mythology told of the approach of Ragnarok, preceded by stars that vanished and new wanderers that took their place. In Christian eschatology, omens in the heavens were said to prepare humanity for final revelation. The next visitor in these frameworks is never just another star or stone. It is a sign, a herald, a precursor. The parallels with our present moment are difficult to ignore. Scientifically, the next visitor offers extraordinary opportunity. With new telescopes, we might catch it earlier, track it longer, and study it more deeply. Proposals already exist to launch rapid response missions, spacecraft capable of intercepting such an object before it leaves again. The European Space Agency's Comet Interceptor, designed to launch in the coming years, may be able to chase a future interstellar visitor, capturing data up close instead of from afar. If successful, humanity could, for the first time, touch a body born beyond our solar system. We could analyze its chemistry, its structure, its scars. We could answer the questions that Oumuamua and 3 Atlas left behind. But with this scientific excitement comes unease. What if the next visitor does not want to be studied? What if it moves in ways that evade our probes, or worse, responds to our pursuit? The silence of the previous visitors already suggests ambiguity. Were they indifferent or deliberate, passive or active? If the next visitor shows signs of awareness, changing course, reflecting signals, responding to observation, then the debate over natural versus artificial will end abruptly. The universe will have spoken, not in theory, but in action. The psychological impact of such a revelation would be immense. Humanity has long looked to the skies with a mixture of awe and dread, imagining gods, aliens, messengers, and omens. The next visitor could collapse that divide, transforming speculation into fact. We may find ourselves confronting not only the question of life beyond Earth, but the possibility that we have already been under observation. The watchers may not come in ships or fleets, but in silent fragments drifting across the stars. There is also the haunting possibility that the next visitor may not be harmless. Both Oumuamua and 3 Atlas slip past without collision, without disruption. But what if the next does not miss? A fragment just a few hundred meters across could devastate Earth if it struck. The arrival of interstellar objects is not just a scientific curiosity, but a planetary hazard. We celebrate their mystery while forgetting their danger. The next visitor may remind us that the line between wonder and catastrophe is razor thin. Still, the mystery dominates. If another interstellar object arrives soon, it will either confirm or complicate the theories that surround its predecessors. If it behaves like an ordinary comet, it may suggest that Oumuamua and 3 Atlas were simply outliers. If it behaves strangely again, the chorus of speculation will grow louder. And if it behaves in ways stranger still, if it broadcasts signals, if it alters its path, if it interacts, then humanity will cross a threshold from which there is no return. The next visitor has become a kind of modern prophecy. Scientists wait with instruments poised, philosophers wait with questions sharpened, dreamers wait with hope, skeptics with dread. It embodies the tension between what we know and what we cannot know, between the science of probability and the human hunger for meaning. Perhaps the next visitor is already on its way. Perhaps it has already entered the solar system, still too faint to detect, hidden among the countless dots of light our telescopes have not yet catalogued. Perhaps in a year, or 5 or 20, it will blaze across our screens, and humanity will once again gather to argue, to speculate, to wonder. And perhaps, just perhaps, it will bring with it not only questions but answers. Answers that 3 Atlas withheld. Answers that Oumuamua concealed. But there is also the possibility that the next visitor is not another shard at all. What if the next is not a comet, not an asteroid, but something unmistakably artificial? A probe that lingers, not passes. A vessel that decelerates instead of accelerates. A craft that does not hide its purpose, but reveals it. That would not be the next visitor in the scientific sense, but in the civilizational sense, the arrival that changes everything. Until then, humanity waits in a strange twilight. We know more than we did before 2017, but not enough to be satisfied. We have seen two anomalies, but not enough to be sure. We have tasted the mystery, but not solved it. The next visitor is inevitable, but its form, its meaning, its message, those remain hidden. And so we scan the skies, restless, wondering not if, but when. The story of the first two visitors has already altered our imagination, reshaping our relationship to the stars. The story of the next will do more. Whether comet or craft, shard or signal, it will remind us that the universe is not silent, not static, not ours alone. The next visitor is coming. And when it does, we may find that the greatest mystery of all is not the visitor itself, but our response to it. What we will see, what we will believe, and how we will change once the universe sends another messenger across the threshold of our sky.